Okay, we are live. So hello, everyone. Welcome. So my name is James Woolard. My pronouns are he and him. I'm the regional lead for the Reactor program across Europe and the Middle East. For those who don't know, Reactors are community hubs. We have 12 locations around the world. We have a mission to upskill as many developers and startups as possible. So hello to everyone in the room here in London. It's fantastic to see people in person again. We've obviously been closed for a while. This is maybe our biggest audience we've had actually in a little while. So great to see you here. And then hello everyone to joining online as well. So we are streaming today's event. So we will try to be as inclusive to people joining virtually as well as in person. So this is the first, I believe, Global Software Foundation Summit of 22, I believe, happening around the world. So we're really excited to be kicking things off. We've got a packed agenda. We've got 4 different kind of keynote talks we'll be running through today, chance for Q&A as we run through, and then we have a panel discussion as well as we go through. So if you do have burning questions, we'll have a little bit of time at the end of each session to maybe answer those, but there will also be a chance at the end of the afternoon to ask everyone. We'll be getting them up there to run through some questions as well. So we will be running up to about 3:15 for the first 2 sessions, then having a bit of a break, then a couple more sessions, then another break, and then the panel discussion at the end. And then that will be followed by some networking and nibbles and drinks and so on. So we encourage you to stay for that. So yeah, I think I did the housekeeping piece, but just to confirm, fire escapes and restrooms kind of as you came in. And then just a kind of general code of conduct, we do kind of encourage everyone to be as polite and welcoming of different views and respectful as we go through. And that applies to everyone in the room, but also in line and any of the chats that may be there as well. Cool. So I will hand over to, we're very fortunate actually to have the chair, I believe, the Global Software Foundation, Asim. He also wears a Microsoft hat. So I'll hand over who's going to do a quick introduction of the Global Software Foundation. So Asim.
Very much. Thank you. Thank you very much. Yeah, thank you very much for being here. It's the first summit and also the first event of all the global summits happening around the world. So thank you all for coming. Yeah. Yeah, I'm just going to give a quick introduction to the foundation itself, in case you don't already have some of the high-level details about it. Our mission is to build a trusted ecosystem of people, standards, tooling, and best practices for green software. And our vision is to change the culture of building software, so sustainability becomes a core priority to software teams, just as important as performance, reliability, security. We just want sustainability to be part of just as important part of the discussion. I'm just going to quickly go through just the structure of the foundation itself, some of our progress today, some of our key projects that we're working on, and also just how to get involved if you're not already involved in the foundation itself. So, why do we need a foundation itself? So if you actually look at what the foundation is, it's a vehicle for collaboration. That's all it really is. If you actually look at the membership agreement, it's just a set of rules for how we will agree on copyright, IP, patent. We will disagree. We often disagree inside the foundation on many, many issues. How do you come together? How do you come to an agreement with all those rules in place? And that's kind of why you want to join the foundation, if you want to collaborate with others and try and solve this problem together. We want to create a trusted ecosystem. I've spoken to a lot of customers, big people, big companies who've been looking at investigating sustainable software for a while, and the big challenge they have is trust. There's lots of stuff that people say, there's a lot of tools, there's a lot of papers, a lot of advice. What can we trust? How can we have that trust? That's our goal, is to kind of create that trusted ecosystem so people can start adopting these systems of working. And you want to increase the market size. Like if you train up as a green software practitioner, we want you to have a job. We want there to be jobs in the world, in this world for this field. If you have a product or service which helps somebody become green and become more sustainable in terms of their software, we want to increase that market size. That's our goal. That's our purpose. We are a sub-foundation from the Linux Foundation. So the Linux Foundation manages Linux, the open source operating system. We are a sub-foundation from them. We are our own separate legal entity, but we got a lot of support from the Linux Foundation. They've been around for a long time. They've dealt with a lot of challenges, and that we get a lot of advice from them. We're structured into 4 different working groups: a standards working group, which focuses on creating standards around green software, one of the areas that's lacking right now. A policy working group, which tries to figure out how do we engage with other bodies, other external organizations, be them regulatory, governmental, or non-governmental. How do we engage? What are our positions on certain policy pieces around the world? Open source working group, which Chris leads over here. Open source working group, which focuses on the open source ecosystem around this space. How do we grow it? How do we encourage? How do we fill the gaps for what's needed to actually grow this space that we're in? And the community working group, which is a lot of what we're talking about. If the open source working group is about growing the ecosystem of tools and software, the community working group is about growing the ecosystem of people. So they're the ones that are arranging things like this summit. They're also working on training and connecting people together and just growing the global ecosystem of people, of green software practitioners. This is just the kind of organizational team in the foundation. We've got a great board, steering committee, and administrative team, and we've got organizational leads for all the different organizations that are involved. And our progress to date. So we've just turned 1. We turned 1. What day is it today? 2 weeks ago, I think we turned 1 year old. We launched a Microsoft Build in Build conference last year, around the same time as that last year. And we launched with 8 organizations. We've grown to 32 now. Our members operate in over 190 countries. We have our membership has a global workforce of 1.5 million. There are now 7 or maybe 8 Fortune 500 global companies. Things move very fast in our space. And our growth has just been incredible. As I said, we started with 8, and now we're actually this slide's old, and now at 32. And we put a lot of effort into making sure we have a really diverse and representative membership. Our board really put a lot of effort into thinking about this. We've got just a large amount of for-profits, non-profits, academia. We've got organizations from the west coast of the US all the way to Japan. Organizing a meeting is very complicated in the foundation. Somebody's always asleep, no matter what we try. And yeah, we just come a long way. We launched in May. The Awesome Green Software was the first open source project. The trademark policy was the first one from the policy working group. The manifesto was the first project from the community working group. And the SAI project, which you're going to hear about some of this stuff today, the first project from the standards working group. A lot of stuff's been going on over the last year, and we've got some great stuff planned for the upcoming years as well. Some of the key projects is, well, this event, the Global Summit that we're running right now. This is one of our major things that we're running, but it's also what this is going to do is this is going to kickstart a global network of user groups. So we now have 25 different locations around the world. All now are little seeds of user groups that are growing up. And as we foresee kind of moving forward over the next year, we're just going to meet much more regularly all over the world and start talking and giving an opportunity for people to start connecting together and really start growing this space. When the foundation first started, we reached out to all member organizations. We said, what is your biggest pain point? What is the thing that causes you the most challenge, the biggest pain that you have? Not what is it you want, but what is your pain? And the feedback we got was measurement. Our biggest pain point is how do we measure the work that we do? How do we measure software so we understand what impact we're going to have? And that's why we started working on something called a software carbon intensity specification, which you're going to hear a lot more about today, which is, from the ground up, a methodology for measuring software, which is built by people who are at the front line, to actually working inside organizations, trying to develop, software sustainably, trying to work within the systems. Like, what are the things that they actually need? What is the measurement method that they actually need in order to help them to get their work prioritized and get investments in the right area. That's what the SCI is. Green software certification. So Sarah and Chi, so this is the I think this is going to be one of the most important projects that we do. So no pressure. This is we're working on certification around the field of green software. So training that you can take, and there's an examination that you can take to demonstrate that you have reached a certain baseline level of skill in terms of green software. And our goal is to have 1 million. Let's say 2023, not the end of 2022. So our goal is to have 1 million people certified by the end of 2023. That really was the goal. This is a mistake. I haven't just changed the milestone. But that's the goal. Is to have 1 million people certified by the end of 2023. If we think of a way how we're actually going to change the world, we're going to get as many people certified as possible, and then that will drive a lot of that what we need to happen forward. That's it. Thank you very much. If you don't already know, you can head to greensoftware.foundation to find more info.
Thank you, Asim. And it's probably a good moment to highlight that today's event is very much a partner event. So there's actually 4 companies being involved in putting today on. So that's ourselves, Microsoft, also Avanade, Accenture, and Goldman Sachs. And so you'll be hearing from representatives of each of those companies as we go through. So I'm going to hand over quickly now to Microsoft's relatively new, super new actually, Chief Sustainability Officer, Muzzadora Jorgensen, or Muzzy, as she's affectionately known, who's going to talk a little bit about what Microsoft is doing in the sustainability space. Thank you, Muzzy.
Thank you, everybody, and great to be here. And congratulations of what you've achieved in a year is incredibly inspiring, and the impact that it's going to have in the world is significant from a sustainability perspective. So really great to be here. As James said, my name is Muzzy Jorgensen. I'm the Chief Sustainability Officer for Microsoft here in the UK. Relatively new. I joined just over 3 months ago. And my role is to not only look at bringing all of the, accelerate the ambitions and the commitments that Microsoft have made and bring that to the UK, but also look at how we can harness all of the learnings and the insights and the Microsoft platform and help our customers with their sustainability objectives as well. And it's really apt that we're here at the heart in Shoreditch of the sort of innovation hub of London at our reactor, which is where we work with and support startups who are finding a lot of solutions to the world's problems. Most recently, we launched our AI for Sustainability cohorts, which are 10 businesses who are all working across a whole gamut of different sustainability businesses, looking at how they can solve some of the gaps that exist in the world today, and working and innovating on the Microsoft platform to do that. So it's brilliant to be able to host you here today for the Green Software Foundation. Now, when I'm out with customers, there are 2 things mainly that they want to talk about. And we know from Microsoft's research that we've recently done that at least half of UK organizations are going to miss their commitments around net zero. So customers want to talk to me about, how can we use IT to ensure that we are being green, and all of the things like this are incredibly important. So for example, moving all of their applications into the cloud are areas where they can save up to 90% of the emissions compared to running it themselves in their own data center. Or how do we use IT for green? So how can we use or innovate around ideas that are going to help us to accelerate some of the commitments that we've made? Now, brilliant examples of this are some work that we recently did with SSE Renewables, working with Avanade and Scotland Nature to look at one of the issues that SSE were finding, in that you may know that there's up to 10 years wait for planning permission granted to go and build a wind farm. And we're so desperate for these alternative renewable energies like wind farms, but there's a bottleneck in those things. And one of the reasons why it takes so long is because there's concern around the biodiversity and the impact that those wind farms may have on the surrounding ecosystems. So using AI and a fantastic work around innovating what it means for the puffin population that sit just off the coast of Scotland, and ensuring, because they're endangered, that that nothing they don't come to harm with any of the wind farms that are there. An amazing solution to develop to ensure that population is being tracked and saving a huge amount of time from the rangers who actually are on the island there trying to ensure that the up to 80,000 puffins are all safe. So that's one way that AI and technology and software can be applied in terms of sustainability in action, and that can be used then and replicated across so many different areas, not only from a nature perspective, but you can see how that can be used across many industries. So hence why, although technology isn't the silver bullet to, as I say, a lot of the world's problems, what it does do is accelerate a lot of the solutions that we need to really quickly find and ensure that we are operating within the 1.5 temperature rise that is looming in order to make sure that we reach that. So with that, I will finally say, I think there's some critical things that we need to ensure that we're accelerating here. The first is innovation, and having you all working on a lot of these and solving all of these problems is critical. The second is the collaboration and working together and bringing down the barriers to doing that is really important. And I think having that culture of ensuring that everybody can be heard and reaching their full potential is something that Microsoft is incredibly passionate about. So with that, I thank you. Have a fantastic afternoon. Really look forward to the discussion and the insights that we have. And I'll hand it back to James. Thank you.
Thank you, Muzzy. Okay. Amazing, cool. So we are remarkably on time so far. We'll see if we manage that throughout the day. So I'd like to invite Jasmine to come to the front now. So this is Jasmine Demon, who's the UKI Technology Sustainability Lead at Accenture. We're just making sure she is mic'd up. She's going to be talking to us about green software imperatives and how green software engineering sets to reduce emissions it's responsible for. Is that correct?
Thank you, James.
Yeah, good. Thank you, Jasmine.
So first off, I'd like to wish the Green Software Foundation a very happy birthday. And second of all, I'd like to thank our co-hosts, Goldman Sachs, Avanade, and Microsoft here for holding this event in London, which I'm really excited to be at. And I hope to meet more of you later at drinks. I'm going to be focusing on exploring the intersection between technology and sustainability and why green software matters so much. So in my role as leading our UK and Ireland Technology Sustainability Group, I lead a team dedicated to using technology and innovation to solve and address the most challenging sustainability business problems. And this matters because beyond the great promise of protecting our planet and people, our research shows that companies with a higher level of sustainability performance across environmental, social, and governance outperform their peers financially. Move on. Moving on to technology's role in sustainability. I think we'd all agree, as we've heard from our previous speakers, that technology is a vital enabler of sustainability at scale, but it's a two-way street. The solution itself needs to be monitored so it doesn't become the problem. Technology can and does create sustainability issues, which we'll talk more about shortly. But before that, let me share some research from Accenture that we've published today. So we polled over 500 CIOs, CSOs, and technology leaders to find out more about how they're adopting sustainable tech strategies and their outcomes. So every organization in our survey ranked technology as either very important or important for achieving their sustainability goals. We found that many companies have already begun to pilot and scale use cases that harness technology to drive sustainability. And there are clear benefits from doing so. Companies that adopt sustainable technology to a significant extent can see an 11% jump in their ESG rankings. And between 2013 and 2020, so a 7-year period, companies with consistently high ESG performance tended to generate 2.6 times higher total shareholder returns compared to those with mid-range ESG scores. So the business case is there for anyone that's unwilling in terms of the C-suite to move forward. We also found that half of all respondents are already seeing returns on their investment in their sustainable technology investments. And these can include different forms of potentially improved financial returns, also obviously progress towards their ESG goals, but also improvements in customer experience, in innovation, in software quality, and actually a real way of hiring key talent in our market. So for the half of people that have yet to see any benefits, what are the challenges that they face? So what we found 3 top barriers for CIOs embracing sustainable tech strategies. First, as was mentioned earlier, there is a lack of industry standards, methodologies, and metrics. And what you can't measure, you can't control. Next, there's a lack of defined solutions to move organizations from where they are to their desired state. 40% of our respondents believe the right solutions are either not available or not yet mature enough. And there's also a lack of talent, skills, and know-how to drive these initiatives. Thirdly, complexity. So nearly 33% of respondents are struggling with either the complexity of the solutions in the market or actually making their legacy estate sustainable. Some have yet to migrate to cloud, and we heard about the benefits of that from their on-prem data centers. And 20% are unaware of the unintended consequences of technology or whether the technology they're using itself is sustainable. This really explains why the work of the Green Software Foundation is so important. The software carbon intensity rating, which we'll hear about later from the team here, is a fantastic initiative, and it really marks a big step forward on all 3 of those counts. Then there's the challenge of technology and sustainability strategies still being developed in silos. We found that only 7% of respondents have fully integrated their technology and sustainability strategy. And that's really a situation we need to address, and we need to address fairly fast, because technology leaders can help really catalyze that change, but only if they have a seat at the table. So, how can companies seize the opportunity and harness the full potential of an integrated sustainable technology strategy? So we think that CIOs, as the catalyst for change, can accelerate this transformation by formulating a strategy with 3 key elements. Firstly, sustainability by technology. So this is all about using technology and innovation to drive the sustainability initiatives required to transform every business's business model. And in that space, we will see many ecosystem players come together to solve for those challenges. Secondly, sustainability in technology. So this is all around making your systems green by design, making them trustworthy, making them fair, making them accessible, and making sure that they're overseen by the right governance mechanisms in organizations. And finally, sustainability at scale. And we spoke about this earlier as well. This is about orchestrating that ecosystem of businesses. Some of them might be suppliers, but equally your peers, technology companies, startups, academia, also non-profit and government organizations, bringing them together to really try and solve those wicked problems of this decade and deliver those sustainable outcomes. So I'm going to spend a little bit of time on sustainability in technology, and specifically on this idea of making software green by design. It really goes to the heart of the paradox of technology today. The more people that go online, the more they use technology, the more carbon emissions come from IT. Now, one estimate that estimates the ITC sector share of the world's carbon footprint has expanded from 1.5% in 2007 to 4% today, and it's on course to reach 14% by 2040. That's a significant jump if we don't kind of work towards the foundation's aims. So what is green software? So software, as we all know, is at the heart of all technologies. And the reality is that companies need to make their software an integral part of their sustainability strategy. Organizations need to adapt green software practices, which we'll hear more of, and to ensure that the way software is designed, developed, deployed, and used will minimize its carbon footprint. After all, when software is run on hardware, any uptick on software use increases the emissions on the devices that it's run. Now, this is a bit of a heavy slide. I'm not going to go into all of them, but we have developed a robust framework which targets both software and the full IT infrastructure. I'm not going to go through all of them, but I'm going to highlight a few. So maybe firstly, the green software development lifecycle. In our survey, 2 out of the 560 companies we interviewed said that they always incorporate sustainability principles throughout the software development lifecycle. So you can see there's huge room for improvement. And what we're seeing is the development of sustainable delivery methods, coaches, similar to how we used to have agile coaches helping our IT organizations now deliver in an agile way. Secondly, I'll mention something around green UI and UX. So really what we need to start seeing is more thoughtfulness in the planning stage of designing, developing, and hosting web pages. Google's reported that using dark and less saturated colors on phones and other devices increases energy efficiency. For instance, running Google Maps in the night mode reduces screen power consumption by a whopping 63%. Then green AI. So we all know that training highly complex AI models and ML models is very energy intensive. We recently conducted some experiments using the publicly available iris flower dataset. And our goal was to identify the various species of iris flower included. Now, we discovered our model required just shy of 1,000 joules of energy to get to an accuracy of 96%. Raising that model's accuracy by just another 2.5% required 15,000 joules. That's 15 times more energy for just a 2.5% uplift. Now, we've got to ask ourselves, is that level of accuracy worth the extra energy? Is it required? Right now, I think the answer is it needs to be a case by case and company by company decision, but they need to understand that that data exists before they make that decision. Finally, on green data, which I'll mention and I'll move on, our research shows that data-driven organizations average more than 30% growth per year. So using data is not going away. And we also know that 70 to 90% of the data that organizations collect is what's called dark data, which is not used for insights or decision making. And so as a result, a lot of energy is being wasted on its transmission and storage. How can we help? So a few examples are eliminating unnecessary data collection and storage, using smaller data sets if you can, and then also looking at your networks and your data transmission methods and trying to use those more effectively. Now, what does green by design and software development look like at the code level? We gathered some of our developers recently for a green coding hackathon. And the brief was to identify less carbon intensive approaches to commonly used but energy intensive programming tasks. And I have a couple of our developers from the hackathon here, and I'd like to invite them up, Nilu and Joshan, to share a little bit of what they found and double click. So if I hand you over a microphone and the camera's there for people who've dialed in virtually, I'll hand over to you, Nilu, for a few minutes.
Hi, everyone. Great to be here. I'm Neela Dwivedi. I'm test engineering analyst at Accenture. And I was part of this hackathon a month ago. And we were 9 teams named after planets. And I was luckily part of Team Earth. And it was in 3 phases. First, we needed to figure out which tool you're going to use to measure your code at component level. And there were 3 code challenges. and we needed to iterate it over and over again to make it more greener. And then the style guide, which we want to explain it later, like how you can make your code a little bit more greener than we actually do on a daily basis. So this is the snapshot of all the things that we did later on. Moving on to next slide. Thank you. So these are not the limited principles that we figured out after a month or like few days of code challenges, but these are the basic and general and most important one, I would say, and not language specific. So first, if I talk about the algorithms, we know that algorithm is the core of our software that we make, and it's very, very important to make it efficient. But not surprisingly, it is actually, it make our code like environment efficient as well if we pick the right algorithm for our application. The next is avoid unnecessary variables. So we all know we work with local variables, global variables every day of our task. But if you use local variables more than global variables, so you are making our planet greener. The next thing is reduce unnecessary operations. So we do all the assignments plus if else blocks. We store the results in different variables, but if we can avoid assigning different, results very well and storing it, and because we are never going to use it again, if we don't do it, we can make our planet greener. So that's the other thing. And the fourth thing I will talk about is code compression. So we all, if we actually do, use fewer bits in our encoding information, decide which data type is very efficient to use, and so does it actually, reduces your memory uses, and in turn, it actually energy efficient as well. So the next thing is libraries. So we all use libraries in our daily basis, Python, Java, and all other languages. But if we compare libraries and pick which is actually a lesser size, it makes our code very efficient, like energy efficient. So these are the principles. And these are not the limited ones. So we can actually, start working to the greener future from our very laptop. So I'll just hand over to Josh and my colleagues, which will explain later things. Thank you.
So yeah, thank you, Nilu. Hi, I'm Josh and Goldman. I joined Accenture last September after graduating university. And I'm currently working on website development for a media and entertainment company. So let's dive into one of our green coding principles. The most significant reduction in energy consumption was found to come from a change in algorithms. Let's take the case of sorting algorithms, which were used to sort a random list of 10,000 numbers. On the left of the screen, we have a bubble sort algorithm, which uses a nested for loop. And on the right, we have a quick sort algorithm, which is a divide and conquer one. Both algorithms were given the same input and they had exactly the same output. The difference is that changing from bubble sort to quick sort reduces our energy consumption from 139 milliwatt hour to 1 milliwatt hour, which is an outstanding 99% reduction in energy consumption. Our key learnings from the hackathon. First, there is passion and interest to implement sustainable practices. Everyone from different career levels at Accenture took part in the hackathon, from Jasmine, who was part of the judges, and from our apprentices who went to university during the day and took part in the hackathon in the evening. Second, sustainability starts at the code design process. Developers often think how they can make their code efficient and how they can make their code bug-free. One other question that could be asked is how can they make their code sustainable? Finally, and probably the most important one is, as a developer and on a personal basis, is that each and every developer can bring change. Like it is often said, when it comes to the environment, it's the small steps which, when added together, can bring significant change. If we take one analogy, if one person switches off the light, then it's negligible. But if 1 million person switches off the light, it becomes significant. And on a similar basis, a single line of green code in a website visited by 1 million people can bring change. So thank you, and back to you, Jasmine.
Thank you to Neelu and Joshin. So I hope you found that interesting. There's a whole load of other information that they found, and they're creating a manual. Maybe we need to send them to you, Asim. Yeah. I'm going to close now. Oops, no. There will be further deep dives today on green software, but I wanted to leave you with a challenge. I'd like, all of us are here because we're interested in sustainability, and we need to take a fresh look at technology through the lens of sustainability. Let's focus on creating and implementing comprehensive sustainable technology strategies, one that makes technology more sustainable and one that uses technology to drive sustainability at scale. Now, I'm sure we're all purpose-driven, otherwise we wouldn't be sat in this room, but I truly believe that as technology practitioners and executives, this is now our core mission. If you want to learn more about the facts and figures and that I mentioned today, our report's been published today, and you can download it by visiting our page, and there's a QR code. But thank you all, and I look forward to further discussions and meeting some of you at the drinks. So thank you.
Thank you so much, Jasmine. That was amazing. Cool. So we have a couple of minutes for questions, actually, as promised. So if there are any right now, then if you just wait for a mic, you want to wave your hand in the air, and we will come to you. If not, we can save them for later on. Yep, we have one here. So we have a microphone coming towards you. If you maybe want to introduce yourself and then ask a question, it'd be great.
Hi there, my name is Seth Birch. The equation that we saw earlier on for the carbon intensity looks very simple, but I wonder how easy it is to calculate. The R value in particular looks difficult to me.
The software carbon intensity equation, one of you able to do that?
Yeah. It's really, the equation itself is quite easy. The actual choosing the data inside it and what numbers to pick for those individual values is quite a challenge. One of the things we're doing in the foundation is there's several projects related to that SCI a calculation. One is called the SCI data project, and through that project you can then say, well, I think my energy number for this type of application is this, or I should pick this number. What do you think? And then we can get various experts from the foundation, because actually the truth is there's not really much agreement anyway. So we're just going to get a bunch of people around and just have that conversation. It's all happens openly on GitHub. That's the biggest challenge with the SCI is the data, and we acknowledge that. Oh yeah.
On picking the R specifically, so month, for example, or API call, we ran a workshop and training session. 4 different groups came up with 4 different answers. So one of the things we're going to try and do is actually recommend different R's for different types of applications. So API, web app, for example. But if you want to get involved, jump in on the GitHub and yeah, chime in. Cheers.
Thanks, Chris. Good question. Okay, we have one more here. Just wait for the mic. Thank you.
Thanks very much. My name's Ben. I wanted to ask about specifically, Jasmine, you were highlighting, I'm not sure if I got these stats right, but you said it's 1.5% of global carbon footprint from data centers, or was it tech as a whole?
ICT sector. Sorry.
ICT sector. Okay. And then
ICT sector as a whole, yeah.
And then you said by 2040 it's going to be 14%.
14% on track.
So obviously that, to me, that's quite explosive growth in terms of the carbon footprint of the world. And so it's this whole question of how we can move things fast enough to do something about that, because that is a very negative picture. And we're talking about how we make sustainability more important, but it feels as if the industry, like, we're not even featuring across the industry as a whole, right? Like, we're a very small group.
I think you're right. It depends on which industry you're talking to. So what we're finding is, for those industries that have large IT estates, financial services, government clients of ours, they're very much interested in moving the dial on software, and they're leading the charge on that. And we're having many, many conversations with clients across those groups, because they don't have a full supply chain like a fast-moving consumer goods organization. So we will see them, and they've got larger kind of IT estates with lots of algorithms they're running. And we are seeing that, I have to say. But where the organizations have manufacturing, automotive, etc., they've got bigger things to sort out. When we've spoken to their CIOs, they need to sort out their supply chain. They've made commitments to the public and to their shareholders on going potentially carbon neutral across their supply chain. And that's a much bigger challenge for them than moving stuff out, into green data centers. So I think what we're seeing is it depends on industry. And I think actually you're right. The position of IT is kind of coming into focus now and moving forward. So I've been doing this role for just over 12 months. 12 months ago, we weren't having the conversations we're having now. And I do think there's going to be explosive kind of growth in these conversations in the next 12 months. When we come next year, we'll probably be talking about lots of different technology projects that we're doing to solve the standards that are being developed by the Green Software Foundation and how we're implementing them into every organization. I'd love to come next year and be talking about that and the challenges we're facing on real live projects, because right now we're talking about strategies. And what's also interesting, as I'm seeing practically every month, our client organizations are putting in place new roles. For example, like I'm going to be meeting soon from a large bank, their global sustainable technology lead, who's newly been put in place. So these roles are popping up, but we're at that. Everyone in here is a pioneer, to be honest. And those roles are coming up. We need to probably be part of that cause. So I think there's movement, but that challenge, that number of 14%, it's an interesting number because it is quite explosive. And what greening the grid isn't going to be enough. It's going to have to be that, plus what we're doing here, and all those things come together. But there's so many things now that happen in the ecosystem. Does that answer your question? I hope so.
It does. There's like a central contradiction there, right? And it's really interesting to try and pick that apart.
Yeah.
And what we can do.
Yeah.
Thank you.
Thank you.
Thank you. I think I saw one more hat. Oh, we kicked the thing. Yeah, we have one more question here. We'll just try and get that back.
Hello.
Oh dear. There we go. Okay, go for your question. Thank you.
Hi, I'm Anna. Just a quick question about the Green Hackathon. Did you find other benefits, such as like faster running code, as well as more energy efficient code?
That's for one of you guys. Yeah. Did you hear the question?
Yeah, definitely. So we found like efficiency and we found that efficiency and sustainability comes hand to hand. So for example, the algorithm that we demonstrated, it was more efficient, and at the same time it was greener as well, because the less time taken to run the code means it's both greener and more efficient at the same time. Yeah.
Thank you.
Yeah, sure.
Hey, Stuart Perks. So on the bubble sort versus, what was it, quick sort, how did you actually measure the power usage at Hackathon?
Yeah, so that's what the first phase of the hackathon that Nilu mentioned. The first phase was finding a tool that could measure energy consumption of code. So the different teams searched for different tools, and the one that we all settled on was called Code Carbon. So it is a Python package which can measure energy consumption of Python code, and that's what we used. Yeah, thank you.
Okay, thank you. That's great. Good questions, good conversation. Thank you everyone for jumping in. Okay, I'm excited to introduce our next two speakers. So we have Goldman Sachs coming up next, and we have Sarah Su and Sui Chan talking about the principles of green software. I think you should be mic'd up. Thank you.
Hello, everyone. I'm Siu Chan. I am a software engineer working in the Prime Services Risk Engineering team in Goldman Sachs. So today I have my colleague Sarah here with me, and we're going to talk about the principles of green software. So the principles of green software are basically a core set of competencies needed to define, build, and run green sustainable software applications. Through the synthesis of this knowledge, green software practitioners can make decisions which have meaningful impact in kind of like reducing the carbon emissions of the applications. So green software principles basically evolve around three main areas, which are energy efficiency, hardware efficiency, and carbon awareness. I'm going to cover energy efficiency and carbon awareness, while Sarah's going to cover hardware efficiency. Before I jump into energy efficiency, first let's look at what is carbon efficiency. So we all know that greenhouse gases warm up the planet, and there are lots of different types of greenhouse gases. The most common is carbon dioxide. In terms, well, if we're going to kind of like simplify the discussion, we're going to kind of like normalize them into what we call as carbon dioxide equivalent. For example, methane is 40 times more warming than carbon dioxide. So 1 ton of methane, we would call 40 tons of carbon dioxide equivalent. So one of the ways that we can kind of like measure the amount of greenhouse gases emissions attributed to countries and organizations is through what we call as a greenhouse gas protocol. It's broken down into 3 different scopes, which basically defines how carbon are emitted either directly or indirectly via different types of activities. Everything emits carbon into the atmosphere. And when we run software, carbon is emitted. So for software to be green, it needs to extract the maximum value of every gram of carbon that is emitted. A carbon efficient application emits the least amount of carbon possible. Next, we're going to talk about the concept of energy efficiency, which is consuming the least amount of electricity possible when running software. So many times, like, we think that electricity is clean because when we plug something onto the wall socket, our hands don't get dirty and we don't have any smell. But electricity is basically the single biggest emitter of carbon. And that is because most of the electricity are still created through burning fossil fuels, mostly coal, and also natural gas and oil. So electricity is the proxy for carbon. If our goal is to be carbon efficient, then our goal should be energy efficient. So how do we measure electricity? The standard unit of energy is joules. A watt is the rate, which means 1 joule per second. And a kilowatt is therefore the rate of 1,000 joules per second. So the standard unit to measure electricity is basically kilowatt hour. The data center industry uses power usage effectiveness, i.e. PUE, developed by the Green Grid in 2006 to measure data center energy efficiency. Specifically, how much energy the computing equipment uses in contrast to cooling or other overhead of supporting the equipment. So when the data center's PUE is close to 1, it means that most of the energy are being used in computing. Another way of thinking about PUE is as a multiplier to your application energy consumption to get the actual consumption from the grid. So for example, in this example here, if it takes 10 kilowatt hour to run your application and the PUE of the data center is 1.5, then the actual consumption of the grid is actually 15 kilowatt hour, where 5 kilowatt goes to the operational overhead of the data center and 10 kilowatt goes to the servers that are running the application. Similar to data centers, there is also the concept in the computing world called energy proportionality. It basically describes the relationship between electricity a device is consuming versus its utilization, i.e. how busy it is. The relationship between utilization and energy consumption is not linear. So as you increase the utilization, the amount of energy consumed doesn't increase linearly. And when computers are idle, they still consume electricity. This is what we call a static power draw, which can be significant. And because of these reasons, the more we utilize a computer, the more efficient a computer becomes at converting electricity to practical computing operations. So throughout the chain, from electricity being produced in the grid to the end user, we want as little waste as possible and more energy to go from one step to the other. The final step is the value to the end user. We want as much electricity as possible to be turned into valuable, meaningful functionality for the end user. So to recap, an energy efficient application uses the least amount of energy possible. Next, we're going to take a look at what carbon awareness is. So carbon awareness is about doing more when electricity is clean and less when it's dirty. So how do we know whether electricity is clean or dirty? We use a measurement called carbon intensity, which basically measures how much carbon is emitted per kilowatt hour of electricity consumed. And not all electricity are generated the same way. In different locations and at different times, electricity is generated using various sources with varying carbon emissions. So some sources such as wind, solar, or hydroelectric are clean, renewable sources that emit little carbon. Other fossil fuel sources emit varying amounts of carbon to produce electricity. So for example, gas burning power plants emit less carbon than coal burning power plants. So the standard unit of carbon intensity is gram of carbon per kilowatt hour. And carbon intensity changes by location, since some regions have an energy mix that contains more clean energy sources than the other regions. It also varies by time because, due to the variable nature of renewable energy, for example, when it's cloudy, the sun's not shining, or the wind is not blowing, the carbon intensity increases since there is more of the electricity mix comes from sources that emit carbon. So for example, in the example here, we can see that the bar on the left has lower carbon intensity because there's more wind and solar power available as compared to the bar on the right. The marginal power plant is basically the plant that would dispatch more energy if you were to ask for more energy right now. Renewable power plants cannot control the sun or the wind, so marginal power plants are often powered by fossil fuels. The carbon intensity in this case are called the marginal carbon intensity. So if your marginal power plant is a coal plant, then it will be higher than if your marginal power plant is a hydro dam. Sometimes we throw away energy because if there is no demand, but there's more wind and solar power available, and we don't have anywhere to store them, we throw them away, and that concept is called curtailment. There's an epic transition happening right now. Grids all around the world are moving from high carbon sources like coal to low carbon sources like solar, wind, and nuclear. This is what we call as energy transition, and we need it to happen as fast as possible. One of the ways that we can kind of like accelerate the energy transition is basically to build applications that do more when the carbon intensity is low and less when the carbon intensity is high. Energy markets are some of the most complicated markets in the world, but what's important to understand is that our goal is to increase investment into lower carbon energy sources like renewables. So one of the best way to kind of like ensure that the investment flows in the direction that we need to is to make sure that we use electricity with the least carbon intensity. So doing more when your software carbon intensity is low and doing less when it's high is what we call as carbon aware computing. We can basically achieve
these through various different strategies. For example, demand shifting. Suppose you're flexible with where your applications are being run. You can basically choose to run your application and consume that electricity when the carbon intensity is less. Spatial shifting basically means to move your computation to another physical location where the carbon intensity is lower. And temporal shifting is shifting your application to run during times when the carbon intensity is low. Doing this will basically reduce the carbon emissions that your software is producing and also accelerate that energy transition that we talked about earlier. So these are a few of the different types of data sources for carbon intensity. You can get them from carbonintensity.org.uk, whattime.org, and electricitymap.org. Next, I'm going to hand over to Sarah, who's going to cover hardware efficiency.
Can you guys hear me? Okay, amazing. Hello, everyone. My name is Sarah Su. I'm an SRE with Goldman Sachs. I put an arrow next to my face in case you can't recognize me because I've aged considerably since that photo was taken 3 years ago. So what I'm going to talk about, so far we've covered what green software is and 2 of the 3 activities that make software green. Oh, sorry. You know, it's the first time we got like a proper stand and microphones. I was like, should I use my phone or should I use a laptop? Anyway, before we shift our focus to the last activity, let's do a quick recap. So we define green software as software that emits the least amount of greenhouse gases possible when running. We can either make our software carbon aware, like what Shu has covered, or carbon efficient. And there are 2 ways we can achieve carbon efficiency with software. The first one is to make our applications energy efficient, exactly what Shu and Jasmine has mentioned. So it uses the least amount of electricity possible. And then the second way is to achieve hardware efficiency, and that is the focus for the second half of this talk. Oh, sorry, 1 second. So every object we come across in our daily lives emits carbon during the creation and destruction of the set device. That includes our mobile phones, the one I just dropped, and the servers and data centers, all the materials that was used to build this space. We call this the embodied carbon of an object. And going back to what I previously mentioned, our goal is to make the software carbon efficient. And one way to achieve carbon efficiency is to be hardware efficient, because we can think of hardware similar to electricity as a proxy of carbon. There are 2 broad categories of achieving hardware efficiency. First one is we can extend the lifespan of a hardware or increase the utilization of hardware. So for most end user devices, the embodied carbon is much, much more significant than the lifetime emission from its electricity consumption. So the strategy of extending the lifespan of hardware is probably of most interest to people building software for end user devices. When an application on our mobile phone is lagging, most of us probably think, should I buy a new phone? So one thing that software practitioners can do in this space is to make sure that applications they're working on also work on older models. An excellent example of an end user device that strives to have a longer lifespan is a gaming console. On average, a mobile phone's lifespan is 2 years, but a modern gaming console is about 3 to 5 years. Let's illustrate this. So if your device has 1,000 kilograms of embodied carbon and an expected lifespan is 2 years, then that's about 500 kilograms per year. If you extended your device lifespan by just 1 year to 3 years, that would be about 333 kilograms per year. Let's do another crude illustration. For example, if we have 5 servers and each running at 20% utilization, the total embodied carbon would be 5,000 kilograms. Or we can have just 1 server running 100% utilization. So the total embodied carbon would be 1,000 kilograms. So by increasing the utilization of a server, we are being efficient with embodied carbon. And this is what we need to think about when we are building applications with cloud computing. And that includes public, private, and hybrid clouds. We need to look beyond the direct emission of running software and think about how do we be efficient with embodied carbon in a given scenario. There are many, many advantages of choosing a public cloud. And one of the main advantages of the ability to scale up or down. We don't need to worry about over provisioning idle servers to meet our software's peak capacity. But choosing public cloud doesn't make your application more sustainable. You need to remember that like going to the public cloud gives you the capability to be more sustainable only if you design your application in a suitable way for the chosen public cloud. So to recap, we can either be carbon efficient or carbon aware, so our software is green. And one of the ways to be carbon efficient is we become efficient with hardware, because we can think of hardware similar to electricity as a proxy of carbon. And today we presented two broad categories of achieving hardware efficiency. For end user devices, you can think about extending the lifespan of hardware. And for application in the cloud, you can think about the ways to increase the utilization of hardware, so the burden of embodied carbon is diminished. So here are the 6 principles of green software. They form a core set of competencies for anyone in tech to understand, so that we techies are empowered to define, build, and run sustainable software. Before I wrap up, I want to share our progress for the Principles project, what we have achieved so far, what our upcoming milestones, and hopefully after today, some of you would like to join us. So why Principles project? The most significant bottleneck to adopting green software practices is the lack of knowledge. We as a community, we don't have the standardized terms, shared language to carry out sufficient discussion on green software. We need a unified entry point for engineers or any practitioners in the tech space to kickstart their journey on green software. So that's how the project came about. We set out to revise and extend the original principles by Asim. He written it in 2019, and we aim to reflect on the feedback and learning we collected over the past few years. Currently, we have finished updating the principle, and then Foundation's tech writer is editing just to make sure what we have written is actually English and makes sense. So while we wait for that edit, we have kickstarted a few other milestones. So as Asim was saying, like the Green Software Practitioner certification. So now we're looking into turning principles into a certification. This is because as more organizations, they look to hire green talent, right? We need a way to evaluate that the software engineers or the software practitioner we hire meet a minimal level of understanding. So that's why we need a certification. Hopefully, by certifying as many people as Asim said previously, by 2023, now 2022, we can have this ripple effect. We have people to talk about green software to their friends and families. So now the revision of the principle is almost complete. We are expanding the project scope to include something called the patterns and practices. So principles are a core set of competencies for us to define, build, and run green software. It's basically a guideline how to do things, but how you actually apply those principles. What are the action advice people can actually immediately apply to their software is asked every single time any one of us brings up principle of green software. So that's where patterns come in. Patterns is going to be an online open source database of how we apply principles to a specific domain, but in a vendor agnostic way. For example, how do I choose a server that is right size for my application to address hardware efficiency? So hopefully you'll be able to find the answer to this in the very near future in our patterns database. But how about like what is the right size AWS EC2 for my application so I can also address hardware efficiency? That's where we envision practices coming. Practices is going to be vendor specific patterns. So principles, patterns, and practices. That's how the project is going to, how we have evolved the project. So yeah, I think that's all I have time for today. Thank you so much for listening. It's actually my first time speaking outside of GS in front of people. You guys being nice enough, I might come back. But yeah, if you would like to join on the project, Asing and I and Shu and Fergus were very nice people, so please do reach out. And if you would like to learn more about the principle of green software, you can check out our GitHub page.
Thank you, Sarah and Sweet. Absolute pro at speaking, Sarah. You should do it again for sure. Okay, so we do have a couple of moments for questions, but we're going to have a little break. So do you just want to hover there for a sec in case there are some questions coming your way? And then if you have any, wave any hands. Yeah, go for it. The microphone coming.
Hi there, said again. I'm wondering if there's any way to sort of find out server utilization for energy proportionality? I think it's not often I actually spin up a VM myself anymore. Often it's in the cloud and it's going to be a VM anyway. It's not actually the actual hardware. I'm wondering, you know, can you get that information out of a cloud vendor these days?
So I guess just to repeat your question, so you want to say like the server utilization, because now we are going to the cloud, it's actually about the VM. So I think we can probably apply the similar principles into the VM, but we will just need to do some sort of like different data gathering. And that's going back to what Asim and Asim has said, like, and Chris has said there's going to be like a data collection within the foundation where you can gather the right data, and hopefully the similar utilization method of increasing it so you can be more efficient with embodied carbon would apply.
Some really good tools there to get that kind of energy information on VMs as well. Google, Microsoft, and Amazon are all doing that, so you'll start to see that maturing over the next few years as well.
Cool. Thank you very much for your presentation. I wanted to follow up on a comment that you made about the 3 different scopes of emissions. So you mentioned scope 3 as sort of the sort of furthest away from your immediate operations as a business. I think it's quite easy for companies who are operating in a public cloud to consider those emissions to be the problem of the public cloud provider. How do you think about that problem and whose responsibility it is, and how to get software engineers and tech leaders to think about that problem as their own?
Well, personally, I think it's everyone has responsibility to kind of like tackle this problem. So I guess first thing is really to, make people aware that there's this thing like out there. There's a greenhouse gas protocol, which basically measures all these things. And I think that it's the awareness that we need to make sure that people have to start with. And then I guess this whole kind of like climate problems are we have to kind of like tackle them collectively, really.
Oh, sorry. Oh yeah, I would just 1 second. So I guess like technology is going to get more integrated into society. Like we are always going to get more carbon, and I think we do recognize that like by having 3 different scopes of greenhouse gases doesn't really apply to this sector, just because like everything is so intertwined. So like what Fergus is going to talk about, like the SCI, so you can see SCI per functional unit. So what we're going to actually think about is like the carbon emitted per API call. Can we decrease that? Because we're just going to have more API calls as next year. We're never going to have less API calls. So I think like greenhouse gas protocol is really difficult for like us to think about. But if you think about the way that per functional unit, per user, per API, per like transaction, I think that's easier for us to like wrap our head around and do like a crude calculation, if that makes sense. And
that's exactly I think this is one of the challenges that a lot of people, a lot of us kind of realized as we've been developing this, is that the greenhouse gas protocol is very, very important. It's an important protocol. Everybody's using it. 93% of Fortune 500 companies are using it. But when it comes to software, it can be quite challenging. Well, I think one example I use also is I work at Microsoft, so I talk to the Windows team a lot, and I talk to the cloud team a lot. And in the cloud team, when they talk about the energy that the cloud uses, it's scope 2. But the Windows team, when they talk about the energy the Windows uses, that falls into scope 3. But I don't care. It's just energy. That's all I care about. It's just energy. So like that's kind of why in the SCI, as Sarah's talking about, we just focus on energy, hardware, and the scopes is a different accounting mechanism which you can use, but we don't really look at it that way. That's how we think about it. It's a great question.
Cool. Yeah, thank you, Richard.
Thanks. Great talk. Thank you very much. The carbon intensity and the showing the difference between countries and their energy productions and states. And I think in the first slide as well, there was a reference to migrating an application between 2 regions in GCP. A couple of questions. I guess the first one is you've got to. It's a lot of effort to do that. When people have deployed applications and there are cross dependencies internationally between data centers, and they've also got to pay egress charges if if you move applications around, where is the incentive going to come from somebody saying in an organization saying, I need to get to the lowest state possible of my carbon intensity for all of the data center deployments that I have?
Well, I think, one of the example of kind of like motivation of actually doing this is probably organization would also want to kind of like reduce the cost. For example, cost normally is one of the incentive that a lot of organizations are kind of like looking at the moment. For example, organizations who are trying to kind of offset their carbon emissions, for example, are paying a lot of premium to do that, for example. So in terms of that, if you are able to kind of like move your applications to, run at locations or at times when carbon intensity is lower, for example, it definitely have a benefit on the cost on that.
I was just going to add, like, I'm an SRE, right? If a customer comes to us, we want a 5 night services, we'll ask them, are you sure? Because you need to strike a right balance between like, you want to like operate a 5 night services and you don't like get any of the hour budget to like handle your incidents, do your release management, all that. So I think similar to what you would say that how can we incentivize organizations to move their strategies? Like we need to basically just throw all the cards out there and then literally strike a balance between why we need to reduce our carbon. And that could be like carbon tax inevitably going to drop eventually, right? And in that depends on how aggressive each country's carbon tax is. And then they will then need to strive the right balance.
Yeah, I think I've got a follow-up question for Microsoft, because I think that if this is going to be a growing phenomenon and people are going to be deploying optimal times to get to the lowest state of carbon intensity, how do you plan to align Azure to that new state?
This has been all the questions I've been getting for the last. This is it. This question is been my last 3 years of my life. So I think the question you originally asked about data sovereignty, and just to add, like those are the correct points. But just as one other point I'll say is that data shifting by region is sometimes it's possible, sometimes it's not. It really does depend upon your use case. Data shifting by time, is far more capable, because then you're not shifting regions. Stand up and look at the camera, all right? Shifting by time is actually quite reasonable. And do you know what time? That's actually why they're called what time. I didn't realize. Do you know? Yeah, there's that's why they're called what time, because what time do you run something? And the other question you're asking is the capacity question, which is right. That's the other the word that comes up. There needs to be there's a lot of questions and concerns that come around capacity, because the idea is if you just told somebody this region's green, then everybody in the world will just run in that region. And the reality is you should just run everything in France, because France is just completely nuclear, and it all runs about 100 grams per kilowatt hour on a consistent basis. So wait, where I was going with this? Capacity planning. Yeah, and there's other things that's happening right now as well. Again, like one of the other principles that we would never have had time to get to it, but the climate commitments and there's other ones. Various organizations are now setting much more advanced targets. Microsoft set a target of essentially what's called 24/7 target, and we called it 100, 101. I can't remember what we called it now. Those targets, by shifting regionally with carbon awareness, helps you meet those targets. So if you're looking for an incentivization to get people to encourage, if an organization sets a 24/7 hourly matching target, carbon awareness and shifting compute helps them meet that target. You need several hours of a workshop to figure out how to join those dots, but those dots do join.
Hold on. Get a microphone.
Yeah, hi, I'm Lorna D'Souza. So on shifting from regions, if it impacts the latency or performance overall, and also for some of our banking clients, if we hit data repatriation issues, how would that solve the problem of shifting from regions?
Sorry, just to follow up on egress, first of all, because it does tie into your question. In a lot of countries, we're actually seeing regulators step in who actually state you can only procure green services, which then means there's a legal reason to actually start to look at shifting, even if there is a cost impact. That then comes to your data sovereignty piece when you were talking about, for example, data repatriation. A lot of the technologies that Microsoft and other cloud providers are focused on, like confidential compute, allow you in your home country to retain a key that allows you to run your compute and your data in other locations, but actually prevent the cloud provider or anyone in that locality from being able to see or access the data. At one point, you could only encrypt data pretty much in storage. Now we've kind of achieved that holy grail, encrypting data whilst you are computing, and that does solve a lot of those problems, although it does also reduce the performance somewhat, which then increases the carbon. There's a trade-off.
Okay, I'm going to call time on questions, but thank you for that. That was amazing, good discussion. So we have got a break now. So we've got 15 minutes for you to get up, stretch your legs. Want to get some fresh air, you can. There's some, help yourself to teas and coffees. So there's a machine there. The fridges are stocked with drinks. We're using aluminium, which is recyclable where possible. So yeah, we're coming back here at 3:30, so 15:30. Okay, thanks everyone. If you all want to start making your way back into the theatre, we'll be kicking off soon. Thank you. Okay. We're live. We're back on. So hi to everyone in the room. Hello to everyone online. I hope you're coming back refreshed, not getting a post-snack slump. Okay, we have our next session coming up. So this is Avanade, and we've got Fergus Kidd, who is the R&D engineering lead. We've been talking about software carbon intensity specification. Over to you, Fergus.
Thank you. Thanks very much. Thanks everyone for coming back. And yeah, so welcome back from the break. Sorry, just a bit of an echo. Is that all right? So yeah, my name's Fergus. I am Avanade's Research and Development Engineering Lead. So that essentially means I get to play with a lot of cool technology and toys. Until recently, didn't really think about the carbon impact of that, but thanks to the Green Software Foundation and some of my colleagues and those of you here today. Ooh. We good? Okay. I'll just try and keep going. Ooh, yeah. Let me just turn that one off. You right? Yeah, okay, can you hear me there? Yeah, okay, that's much better. Awesome. So yeah, my name is Fergus Kidd, and I work at Avanade as our Emerging Technologies Research and Development Engineering Lead. I'm just going to skip over this because I think we've covered that in the previous sessions. But what I did want to start with is a couple of ideas around what sustainability and technology have, how they go hand in hand together. So first here is sustainability in technology, and this is what I'm specifically going to be talking about. But there's also sustainability with technology, and that's the idea that Jasmine mentioned around using technology to improve sustainability in other areas, whether that be, energy usage, fuel consumption, but in other areas. And today what I want to talk about is specifically sustainability in technology. So, reducing the actual carbon impact of our technology stacks, in our applications, in our cloud services. And this is where the Green Software Foundation is making large amounts of impacts, and again, open invite for everyone to join in some of the projects. I'm going to talk today specifically around one of the projects that we have going on at the Green Software Foundation, but there's actually a few projects going on around carbon software intensity, which I'll dig into a little deeper. So Asim has mentioned a few of the scopes of green software here, and we've just highlighted some of the ones that we are particularly interested in. So for example, the actual software that we're using, the actual energy usage of the applications of any cloud compute that we have. There are elements of green software that we don't have there are elements of these scopes that are not in the scope of green software, things like water use. So you may have seen on the London Underground at the moment, there's a really big campaign about getting a upcycled smartphone and how much water that saves. So there are other impacts of green software, things like single-use products. So I don't want to make you all think too much about the carbon intensity of the snacks and drinks you're having. But we have to think as well around some of those things like business travel and some of the other ones. But today we're going to focus on software and energy use and link those back to the principles. The next thing I want to talk about is continuous integration and continuous deployment, because that is the specific project that I'm going to talk to you around. So what does this actually mean? What does this mean for developers? Well, this is going on all the time. All the pieces of software that we use every day, whether that's apps on our phone, email applications that we use for work, will have some continuous integration, continuous deployment behind them. So it's this idea that as a developer, you can change maybe even a single line of code. And there was some automatic process which will go off and build that, test that, make sure everything's up to scratch. And if our tests are passed, then we can go into a continuous deployment. So we can actually release that code, deploy that as an app. As an example, on your smartphone, you'll get automatic updates all the time. The software on your phone is constantly being updated, whether that's to make it more secure, whether that's to make it more efficient. So I just wanted to highlight this part of CI/CD, as we call it, where we can go from a developer making small changes or improvements to code to a fully deployed app. Back in at this stage in technology with tools like GitHub, Azure DevOps, all sorts of tools now, this is a very automated process. So quite often what will happen is a developer will submit a piece of code to GitHub, and then all of these things will kick off automatically. So the developer actually leaves the code at the point of code and then just sort of magically gets to the deployment, which is the uploading to the cloud. What does this mean for SCI, software carbon intensity? We've heard quite a bit about that today. What is it? Well, actually, it's a specification of a methodology. So a way of describing how our systems are using resources that equates to carbon. What are we trying to achieve when we're talking about SCI specification? Well, that actually goes back to the principles that we've already heard about. So energy efficiency, just to repeat them, energy efficiency, hardware efficiency, and carbon awareness. So the idea of how much energy we are using, what does our technology stack use in hardware and how much embodied carbon is in that. And then our carbon awareness. So this idea of ongoing adaptation to the way that our applications or software are interacting with the carbon. So we've covered up some of the steps required, but basically what we need to do here is decide first of all, what we're covering. So what are we actually interested in measuring SCI for? Is that our whole end-to-end application? Is it, preferably it should be everything that a piece of software touches. We then have the scale. So we talked about that in a couple of the questions that came up. This idea that we're measuring per API call, per button click, per user. That's really important on how we define that, because that's what as Sarah mentioned, that will always be growing. So if we have a new, AI API service, our expectation is that the number of API requests will be always going up. So we're always going to want to get the SCI down to reduce the environmental impact of that. How are we actually going to measure that? We've had some great questions around what do we actually need? I think the key thing is data, right? We need to know how much, we need to know what resources our cloud compute is running on, how much energy that's using, and what the carbon impact of that looks like. And then how we actually want to quantify that. So using some of the principles that we've heard about, using standardized metrics to actually get a measurement back. And then finally is reporting. So actually being able to give that back to developers or whoever is in the product cycle to enable them to make decisions about that. We've then got software boundaries as well. So that's this point of we have to include everything that the software touches, whether that's data systems, whether that's data centers, all of the networking, so many different parts of an application lifecycle that we just don't really think about when we click deploy. When we upload to GitHub, we just kind of forget about it. In the same way that we don't often think about the carbon embodied in the products that we're using every day. You know, when we jump in our car, we are perfectly aware that we're going to burn fuel and use carbon, but we don't necessarily know how much or what impact that has. And then the core characteristics. So what we want to keep is that SCI maintains sensitivity to the carbon awareness. We take a systems impact view when we're looking at that, and we're encouraging the use of granular data. So the more granular data that we can get around the pieces of hardware that we're using, how much energy is being used in a particular calculation, the better, because we can make more informed decisions about that. So how can we actually leverage this once we have it? Well, we'll go back to the principles. We can take actions to increase the energy efficiency. We can take actions to increase the hardware efficiency, so maybe reusing hardware that exists or prolonging the life of that hardware. And we can also take action to increase our carbon awareness and make changes depending on what is happening. So it's really this process of when we're writing software, we're measuring the carbon intensity, and then we're actually taking action on that. So what does that look like when we get to this magical stage of we've deployed some code, we've uploaded it to the cloud somewhere, and we've forgotten about it? Well, every time we do that, we will have resources associated with that. So whether that's silicon, whether that's a database, an algorithm, it's the sort of thing that the Hackathon team were talking about, or just the networking in the data. Often when a developer clicks deploy today, that will just happen. It will be deployed, start running at full scale, and that will be the end of it. So what this is really about is actually measuring that, measuring the software carbon intensity and reporting it back to the developers and the decision makers to allow them to make decisions and take action and make changes. This is also useful from like a costings perspective as well, because quite often you don't actually want tons of algorithms running all the time and incurring huge costs on the cloud platforms as well. So what does taking action actually look like? It may be as simple as moving some of your resources. So you might want to move things geographically to reduce the carbon impact. Some of that you may not be able to do. And then also scheduling. So a really good example of this is that problems like the traveling salesman problem, which some of you might be familiar with. So this idea of if I have to visit a certain number of locations, what's the most efficient route? These are quite large algorithms when you think of large delivery companies, the likes of Amazon, or like grocery delivery companies. These algorithms have to run for significant amounts of time. They take a lot of compute power. You can do things like run them in different locations, but also run them at times when you know they're going to have a lower environmental impact. You'll know before you start it off that that calculation is going to take 4 or 6 hours. You can actually schedule that ahead of time if you can make predictions or you have awareness of the SCI in different locations and different areas. So what are we trying to get to as part of this? Well, what we want to do is add in that CI/CD pipeline for this specific project is a new element to the code, build, test, release, deploy of a CI/CD pipeline, which is assess. We want to be able to assess the SCI, the software carbon intensity of a proposed system before it's deployed, and actually feed that back to the user before it gets deployed so that we can make those decisions about reducing the SCI as part of that CI/CD pipeline, and we can get to a more efficient or a more carbon neutral place before we actually get to that deployment stage. There are other projects in the in the Green Software Foundation going on, which I'll talk a little bit about, to take action on existing and deployed applications and technology stacks, but this is really about giving developers the opportunity to take action before that deployment is made. So it's sort of like a predictive service of can we predict what our SCI before we actually deploy. So lots and lots of stuff going on in the Green Software Foundation. I've pulled out the part of the project that I've been speaking about specifically with CI/CD pipelines. So what technologies are we using? We're using things like GitHub on Azure repos, GitHub Actions, and Azure pipelines to integrate that into the existing CI/CD pipelines. So these are tools that developers will be using every day. And what we're doing is hooking these tools to calculate the software carbon intensity into those tools that developers are using every day, so we can make those predictions and feed those back. There's a lot of other projects going on in the Green Software Foundation about how we can do this for existing technologies that have been deployed, existing applications, existing cloud structures. There's also work going on, as the hackathon guys highlighted, how you can actually bring that information right to a developer whilst they're writing code. So things like software carbon intensity of algorithms and functions, in the same way as when we're testing speed, can we test what the SCI of that is? And then also things like, can we offset the carbon? If we know how much carbon we're generating as part of a particular process, can we actually offset that using some APIs and external partners and do some interesting things? So this question's come up a little bit, but I thought I'd just cover it again, is what do we need to calculate all this? Well, data is key. This is an example of the electricity map API, what you might see on that, which has been mentioned a couple of times. So you can see here, we've got Europe and the carbon intensity of electricity production in each country. So we can actually get this data real time. We can also look at historical data, so how shifts occur over time during the day. So, Asim mentioned that France is a great example. It's always green on there because the large amount of nuclear. But you can make predictions about, in the day, we know there's going to be more solar power available. We have some idea of how the weather is linked to wind power production. So we can actually use these to make predictions about where to move resources or when to schedule resources, as well as looking at the live data and actually calculating what our SCI is at any one point. The other huge thing that we need to know is actually what resources are we running on. So if I just go back here, quite often as developers, when we click deploy, we're aware of what the resources are. We're aware of what our algorithms are, but we don't really know at that point of uploading to GitHub where that code's going to be running, what silicon chip that code is going to be running on, which all have an impact on the SCI, both through the energy usage, but also through the embodied carbon. So if you imagine running a huge AI training algorithm, in our minds, it's just somewhere in the cloud. It's Microsoft's problem, it's Amazon's problem, it's Google's problem. But this is all about bringing that actually back to the developer to be able to make those informed decisions. So if we have some information about what chips we're running on, what server stacks we're running on, what VMs we have running, then we can start making the calculations. So that's just represented in this picture of a server stack. What hardware are we actually running on? How much energy is that actually using? How much embodied carbon is that? And that's all really important information and data that we need to know and to utilize for this process. And what else do we need? So this is my call to action to come along, get involved. This is just one example of one of the projects that's going on in the software carbon intensity space. There's also projects to make an SDK for adapting services and existing technology stacks to the information that we see in tools like Electricity Map and moving things from regions and scheduling them. So please, if you're not already a member of the Green Software Foundation, come and join us, get involved in our working groups, have a look at the projects that you might be interested in, and yeah, come and join us.
Thank you. Do you want to stay here for a second? Okay, so thank you, Fergus. That was awesome. Any questions, Fergus? One at the back straight away. Hold on one second. We have a microphone coming your way.
Hi there. Graham Collins from UCL. It's just an observation. I really liked your talk, Fergus. But if we look at the map where there's a strong correlation with air pollution. So one of the advantages of moving towards more sustainable electricity usage is that those areas that you pointed out in darker colours like Poland, North Italy, are also areas of heavy air pollution, which contribute to lung illnesses. And so there's another aspect of moving to sustainability to help the planet, but also to help human health.
Yeah, absolutely. I also have a strange personal fascination with lithium batteries and the environmental impact of lithium batteries. And you're quite correct. There's more than just carbon. We talk about in the principles of carbon equivalent. There's gases like sulfur hexafluoride, which are used in the electricity, like pylon stations, or what do you call them? Electricity substations, which are several thousand times more of a greenhouse gas than CO2. But also in our hardware, similar to the point I was trying to make around water and the apps that are on the tube about how much water consumption goes into that, there's also toxins, pollutions, depending on where those are made. Lithium is a really interesting example because so much water actually goes into the processing of lithium. They essentially have to pump billions of tons of water into the ground in order to extract the lithium salts from the earth. And it's just, if you look at the numbers, it's just vastly unsustainable. Yet, as a society, we are completely addicted to lithium batteries because there's nothing better at the moment. So great point, and thank you for that.
Cool, thank you. We have a question online, actually. I'll need to come out of here. So, is that it, Rav? There's a lot of comments. Do you want to grab it? You see what you're missing out on of the online chat there. You could do both, maybe. Yeah. Okay, here we go. So a question for the Avanade speaker. Modern software is built on so many layers, of which each generally only know about the layer immediately below it. So there is a huge challenge in terms of tooling to allow the data collection about all of the components and layers which are within boundary, particularly hardware, to be automated. Any progress with big cloud vendors and getting them to provide this info in a standardized programmatic format?
Yeah, awesome question, and very true. I'd say yes, absolutely. We are starting to see more and more data being made available, which is absolutely crucial to this because we can't really do some of this stuff without the data. And I think it comes back to like the environmental strategic decisions that are being made. Like companies like Microsoft have made strategic decisions in order to reach a sustainability goal, and part of that, I think, should be releasing that information and releasing the data about what is actually being consumed, what is actually being made available. Seems like smiling at me, so I'll maybe leave him to answer that one as well. But I think yes, it's absolutely an essential part of this. So it's something that we can calculate ourselves, though, because we, by looking at what we've deployed on Azure or any of the cloud providers, by looking at actually what is consisting up on that, what the silicon is on that, what type of chips they are, we can actually calculate that ourselves if in doubt. And then the challenge for the Green Software Foundation will actually be to get to that point of standardization, because I think every provider, every hardware manufacturer is going to give us that. It's the same information in slightly different ways. So I think that's one for the group of people who are interested to make sure that that is standardized and normalized in some way by actually applying the principles that we've talked about.
Cool. Thank you, Fergus. Another one here. Hold on one sec.
There's also the SCI data project as well, which is bringing this together as well.
Yeah, thank you.
Hi, Ashley Marsh. Given a lot of this relies on data and there's going to be challenges sourcing that, how easy is it to actually operationalize this on a project? Because as I talk to people are hesitant to do more work, add more tasks in, more processes, etc. how is this going to be something that's simple, plug and play, easily source the data, easily provide the data to the developers, which doesn't require them to go, let's say, do another half day's worth of work on a user story, etc.
Yeah, so it's a really, really good point. And I think, for the project specifically that I've been talking about, we have a real interest and to make it as simple as possible in existing tools. So trying to keep it as agnostic as possible to providers, but by targeting the most popular tools like GitHub and Azure DevOps or Pulumi, different technologies which are the most popular, we're hoping that we can just make it as easy as possible. I think there's a really good question in there around the reporting. How do we actually standardize that to make it engaging and interesting, and that's something that people will actually look at as part of this process and not just ignore? But the point that I would personally like to get to is just that it's a kind of checkbox thing that we turn on as part of our CI/CD pipeline, and then that we make it culturally part of our process when we're deploying to check those things out. I think interestingly, there's a business case there as well, because at the same time as thinking about SCI, we're also thinking about cost, right? Reducing the number of idle virtual machines that are just racking up costs for no reason. VM's a great one because you get charged the same if they're doing nothing or loads of calculations at once. So hopefully there's enough of like if we make it as simple as we possibly can using the existing technology and not requiring people to, add something to their software, add something to their code, but only to add it as a checkbox to their CI/CD pipeline, hopefully it can be something that's very easily to operationalize, very easy to adopt, and very easy for developers to use.
Cool. Okay. Maybe one more quickly. Okay, two more.
Hi,
Please, quick,
I'm Sandhya from Avanade. You mentioned about SCI score. So could you elaborate a little bit on, is there a particular tool identified or the scaling mechanism, how a developer would go about getting a score for their code or the entire system built?
Yeah, I think that's a question that's kind of yet to be completely answered as part of the project. So, I'd encourage you to get involved and try and help figure that out. I think, as I was sort of saying, is we're trying to, or the methodology that we're using is to try and to tackle the largest first. So, GitHub as a platform, the larger cloud providers, and then we'll keep adding abilities onto that. So it's kind of yet to be defined, I guess, is what that actual reporting looks like. But essentially what it would be, or what we're aiming for, is to have, for this particular project, would be per 24-hour period or per hour, whatever you want to look at, this is your predicted software carbon intensity, whether that's in sort of grams of CO2 equivalent. And that number then allows developers to make decisions about what they're deploying, where they're deploying it to, and the schedule, so that they can try and reduce that before it actually ends up being deployed. Some of the other projects in the Green Software Foundation will be more about giving a real-time feedback of your current software carbon intensity, which would be like a score essentially, which would be grams of CO2 equivalent per hour, and then give you the tools to actually reduce that.
Cool. Okay, and then one more. Hi.
Sorry, this is more of a point rather than a question, but there is a university in Spain that have made a green software SonarQube addition to Polar requests. So there's something to examine if you want, even before the CI/CD. There's like a paper about it. Yeah.
Cool, very cool. Yeah, I'll come and find you to talk to you about that then. Thank you.
Cool. Thank you, Fergus, and for the questions. Okay, so we are on the final script. So Richard, if you want to come up. So our final keynote before we head into another break, and then we just have the panel discussion, is Richard Conway. So Richard is a Microsoft MVP, most valued partner, but he has a day job as well, which is director at Elester Cloud. He's been talking green design, I think.
Yeah, cool. Brilliant. Thanks, James. Okay. Oh, that's the wrong way.
Wonderful, thank you. Okay, so so a little bit about me. I am a Microsoft Azure MVP and a Microsoft Regional Director. I think it's great that this initiative is really founded from its roots on open source, because it's carrying that culture that has been really pervasive in the development of the cloud, which is why Microsoft, basically building on an open source stack for a lot of certainly for a lot of the data products, which I deal with day to day. So it's really nice that this is part of the foundation of this. I'm standing in today. I had a co-speaker. Unfortunately, she couldn't be here. She knows a great deal about this topic, so I changed all her slides around and put my own slant on this. But I hope to give you a little bit of insight. And just to give you an idea of the way that I think about sustainability, the last few years, I've been on the other side, not on building green software, but building software to help solve sustainability problems, specifically around ESG and more lately, more aligned to Microsoft's cloud for sustainability strategy and scoped emissions. Okay, so there's some absolutely great material from the Green Software Foundation. I'm going to present some of that and give you my spin on some of the things that I deal with day to day with my customers. So, so this is all about designing and building more sustainable digital services, and we're going to focus on different elements of this, from hosting, design, and development. And very cliched, but the internet is polluting the environment, and we'll look at some facts and figures to show that the growth in compute is absolutely tremendous, and it's not something that we can curtail because we can't turn the lights off, business doesn't stop, so we have to think about all of the things that the GSF is bringing to the fore at the moment. I'm not a scientist, so I'm not going to try and describe the intricacies of this, but all of these things are incredibly important, and it was really interesting before hearing about, I think it was on the first talk with Accenture, about the wind farms. Don't want to get this wrong. I think it was the first talk, because I remember for the last couple of years, I've worked on as a facilitator for Sustainable Finance Live, and we've had a lot of understanding around these sorts of financial challenges, and the biodiversity surveys that wind farm engineers can end up doing, are so essential to this piece. So talking about a 10-year lifespan on putting these wind farms up, these seem like bottlenecks, but the huge repercussions, even though we're talking about one aspect of this, which is greenhouse gases, but there are huge repercussions if we don't think about everything like the biodiversity loss. When we try and solve other problems, when we try and fix some things, we might actually break others if we don't think about this as a holistic thing. We need to think about the impact, and if we think about data consumption, it's 38 times greater than 10 years ago, and sites have a size that is 4 times higher than a decade ago. I mean, these statistics are really scary, and I think when I teach some of the Microsoft content, there's a slide that you come across, which is something in the order of, over a 5-year period between 2020 and 2025, you have some inordinately huge number of zettabytes of data that businesses are going to process, but currently only 30% of this is actionable, right? So you can imagine, as more and more companies get more attuned to their data strategies, that number is going to grow. It's going to lead to more compute, and all of the sorts of frameworks that we've been discussing are going to be more essential because they're going to have to operate at scale. So I just wanted to split up, and we've heard this today, and I've in this idea of indirect effects and direct effects, and I've sort of put all my biases there because there are a lot of businesses that that provide some of the statistics and metrics that I see day to day in sustainability, and you need inordinately large amounts of compute to just create these statistics alone. When you're looking at corporate behaviors, when you're looking to try and understand the sorts of things that companies are putting out into their disclosure reports, you need to analyze news feeds, you need to analyze social sentiment. So just to actually get a complete picture of how you can action how you can action metrics to make technology work for you, to give you sustainable outcomes, involves processing a huge amount of data. So you get this direct, which we're talking about today, which is software, but you also have indirect, and there's a connection between them because all the reporting that we do is very, very computationally expensive. We need to raise awareness about businesses' digital footprint. And I think whilst you can see that this is emergent, as a phenomenon, the GSF has only been present for about a year and trying to raise a lot of consciousness. And it was really interesting to understand that there's 25 sites now, and that this is a global phenomenon. And I guess everything starts grassroots, but all of this needs to be raised as a priority. And coming from someone who deals day to day with a lot of issues, right, with not enough people in technology to do the work that needs to be done now, it's important to understand that probably the priority for a lot of the things that you're hearing is down here, because people are up against deadlines. They've got combinations of software code quality to deal with, secure code, ensuring that infrastructure is code present. So because of all the rigor and the serious deadlines that most software developers have, understanding how to make this as easy as possible by creating the right abstractions is key, I think. I don't think we need to even challenge this. I think that all of these things are going to coalesce, and the more and more we go through the software process, the more I think that we're going to have new norms, we're going to have new pressures, especially from some of the largest enterprises who I hope are going to join the Green Software Foundation and a lot of like-minded organizations, because I think all of this has to be pervasive from the top. So I think the first thing is, as you start really beginning to understand whether or not whether your software design process for a particular piece of software is essential or not. So I've been in so many software projects where everything is built from the bottom up. I think we all have, where we've started looking from an enterprise picture. We've looked at building blocks and frameworks, and this isn't really the most efficient form of design. You build it and they will come. I think that more and more companies are beginning to realize that that kind of software, whilst great when you've got a large number of users, right, is actually better from the top down, where your customers are actually building the platform as you go along. And I think that one of the things that this exposes is the fact that you think about building that software in a different way from a platform perspective, and the sorts of backlogs that you create are different as a result. They tend to be smaller, more focused on particular use cases. So I think the more this type of design, especially in the cloud, becomes pervasive, the quicker and better software designs we're going to see. Okay, so we've heard a lot of talk about shift to renewables. We've heard about carbon intensity, software carbon intensity, and I think one of the things that we get with the cloud is we get some very, very clear answers with all of these. And so we heard about the equipment reprocessing. Microsoft from the ground up have gone through so many evolutions of actually having this data center in a box, right? That you just plug onto a lorry, you drive it into the back of a data center, it hits these power cables, and then boom, you've got a running set of servers, right? Nobody touches them until they reach a certain critical mass of failure, and then they're recycled. And they've been very, very open about how they've gone through this, these generations. Initially, in the early days of Azure, they called this global foundation. And they used to actually build these from Gen 1 all the way to Gen 4 and then beyond. And the data centers themselves, they're built with natural wind tunnels in mind. So you have like all of these weather types of coolant. So there's so much thought, right, in how to, that's not even captured when we talk about renewables. There's so much thought in the site planning itself, and how nature's going to provide some of the need not to expend so much energy, that we can also factor into the decision of hosting, because only the biggest companies in the world can afford to think like this about where the sites that they plan and whether they're going to be in natural wind tunnels. And so just one of the things that there's a lot of material within the Green Software Foundation, and I've gone through this. It's very, very, it's very, very focused on web and a real understanding of localization of data and localization of services. And this is absolutely key. So you've got where you think about hosting. You need to think about where you're going to put something, right? The least number of hops is important here. So the cloud having that global footprint. I mean, we talk about the carbon intensity and being able to move things between data centers. It's equally important to say we actually need to have our compute as close to our users as possible. So the ability to basically point and click and say, I'm going to deploy there or there or there or there without having too many localized hosting providers, really, really important. And similarly, for things like static content, for CDNs, they're obvious, right? But we don't always use them. But when we distribute static assets, right, which especially in the web, there's so much of, being able to put these assets as close as possible to your users is incredibly important. Remember, this is about not just about limiting the amount of latency that your users have to experience, but it's also about reducing the number of hops that somebody has to do when they make a web request. So what I've done is I've really thought through from the perspective of actors about the efficiency of design patterns, and I'm gonna throw this at you. There are so many variations of this pattern. It's a Microsoft pattern. It started in incubation in 2015, and it's called the Modern Cloud Data Warehouse. It's based on something called a Lambda architecture, which has 3 layers, which has a serving layer, it has a batch layer, and it has a real-time layer. And all through the last 6 or 7 years, some of the little boxes on this diagram have changed, but the whole emphasis pretty much remains the same. I wanted to talk about this because being a data engineer, it's really, really easy to misuse this pattern. Where to understand the use of effective compute, and I'll just draw a generalization here that less use of compute, right, is less use of carbon, even though we've heard from people that the equation is a little bit more complicated than that. One of the things that I see with what I'm doing is that the most amount of compute in the cloud is expended through this pattern, We can talk web, we can talk software integration, right? But companies are doing this en masse, right? Companies are operating through this pattern en masse. And what you've seen is you've seen a shift in skills from people that understand and rationalize how to use relational data, how to build data models, operational databases, and also analytical models, to using big data. But even though big data has been around now since the early days of Hadoop, it still hasn't caught up into our consciousness. And there's a lot of people that take this pattern and misuse it. I see it all the time with a lot of my customers, because in this, when you mess up in this layer, you can go between using 10 VMs for a distributed query to 100 VMs. It's literally that easy, because you don't understand where your data sits, how it's localized, how it should be partitioned, how it should be optimized. So this is not just about understanding carbon. This is about understanding good design, right, and education as well. It's very we can probably do more from teaching people this architectural pattern and practice and how to use big data properly, no disrespect, than we can from some of the key tenets of the GSF for now. And that is because too many people misuse this. And there are some simple things that we can take away from this, right? We need to think with this pattern about optimizing queries and query plans, right? Every single time we don't do this, we have to redo it, right? Databases, relational databases are designed to cache their query plans because they're expensive to compute, right? It could take 20 seconds. It could, depending on the type of query plan, it could take a minute, right? But they're specifically designed to cache this. If you misuse your big data, you can have hundreds of people doing this over and over again. Keep data close to the compute with multiple copies, right? We're in this Web 2.0 phase, right? For the last decade, we've been talking about using NoSQL, right? Having data replicas. When storage is parked and you're not querying it, right? It's not computationally expensive. So it doesn't matter if we have different views that are replicated, right? For different users, it's actually cheaper computationally to do that than to get a database working, running, crunching numbers, giving people different views based on what their needs are. Indexing. We've all been in that position where we've written a query and then a DBA has gone da, 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 right? And you've gone down from 3 minutes to about 10 seconds on the response, right? It's important. The more that we can push to storage away from the compute by saying this is there, this is there, this is there, right, the better, because we want to be pre-computing things once. It's expensive to keep doing this over and over again just because somebody's requested the same thing or something slightly different from the last user. Partitioning in big data in this pattern, right, is, I cannot tell you how important this is, right? If you get this wrong, whereas with a relational database, right, we deal with a scale-up methodology, right? We look to have a bigger and bigger relational database. With a big data platform like Spark, Synapse, Databricks, what happens is you scale out. And that linear scalability, if your data is all in the wrong place, it's not partitioned correctly, right? You will need more virtual machines to do the same amount of work as somebody that does this efficiently. You'll need to write intermediate domains into this as well, because your data is not in the right place at the right time. So the key thing here is that whenever you do this pattern, and I'm telling you from experience, right? This is the thing that people are doing and spending more time and money on in the cloud than anything else. So whenever you do this, you need to think about that new level of efficiency, which is that linear scalability and how it works. Then think about curating everything, right? It's important that when you build data platforms, you you compute your output and you give it to people, right? Because otherwise, if you stage this data and you give them the ability to say, I want a view and I want it to look like this is my interface, they'll compute it over and over again. Then if you have your second user, right, you'll be doing it twice. Okay. Sorry about this mess. I took this from I took this from another talk, but I wanted to really hammer home the point that we've changed the way that we think about software integration. So that was from the perspective of a data engineer. From a software engineer, very, very different. It's all about building blocks. So if we take the building blocks in Azure and we start thinking about how we build microservices, something like this is really interesting, but you can see all the crosses, right? What this is it's a set of function apps in Azure, and function apps have certain software designs, right? Certain levels of durability. And if you use software patterns that Microsoft provide, right, it's fantastic. You don't need to worry about the retries, right? You can make sure that you've almost got an atomic operation through this from start to end. Now, if I decide to build this myself and I have to make 400 of these calls, right? I'm running 400 processes concurrently. What happens is I have to monitor the retries. I might get to that point in the middle and I might have to fail everything because of the way that I've designed this. And this is another thing that I see. I see that a lot of software developers are looking at these patterns, not taking into account a lot of the architectures that have been published online, which are there to solve these problems. They're abstractions which say, if you use this software library or this software library, we'll invisibly build some queues in between, right? And you won't have to write a linear backoff algorithm or an exponential backoff algorithm. And what this means is that instead of here spinning up 400, 800 processes, right? And retrying and retrying and retrying, you're only doing this for 1 or 2 processes because of the architectural pattern, okay? So it's important to follow the instructions. Okay, the last one was my little bugbear because I'm very, very tired of having a lot of my customers talk about cloud lock-in. And I think that one of the things that we have to do is start trusting the cloud vendors more and understand that the more that we delegate to the platform, right, the better our carbon impact is going to be. Because I'd rather have Microsoft thinking about these things than me, right? I've already told you it's not high on my priority list. I want an abstraction, and these are the things that Microsoft can afford to put into the cloud. If I start running my little practice in my company, and I make everybody aware, and I'll make them build all the software abstractions as well, right? It's hard for me. So to be able to delegate to the platform, I think is the right way to go. So just to, I was thinking when Fergus was doing his talk, because I wanted to just say that, a key piece of being able to move and migrate software, one of the important things is to commoditize that software, right? It's absolutely fantastic in this day and age that we can write infrastructure as code and that we can take a snapshot of the state of our software and we can deploy it anywhere, right? So we can literally make this independent from the data center. One of the things that I was thinking of, which when I put these slides together, was, I didn't, because other people were asking questions, I never posed the question, but I'm in customers who have hundreds and hundreds of build boxes, and they use pools within Azure DevOps to do build and release deployments, right? And maybe we should be thinking differently about how we trigger our code releases so that we're actually using less compute rather than think about this as continuous deployment anymore, because they seem to be slightly at odds when we're trying to reduce the amount of compute. Just a thought that popped into my head. Darsh isn't here to explain this slide, but I think one of the things that we've seen is this huge increase in data science workloads since 2016, and especially the use of neural nets. So I'm just going to sum this up by saying, as we get more and more and larger models like GPT-3, they're very, very expensive. We need to think about them. We need to think about when we use GPUs and N series in Azure, because they do consume a lot of power, and they're designed in such a way that they can run for days and days and do lots of iterations. So we really need to think about whether or not, I think somebody made a point earlier about whether or not, tuning a few hyperparameters and making a machine learning algorithm a few % more accurate is actually worth the cost of carbon in the compute. So for me, I would say green design as well means common sense design, right? We want to minimize our operational overhead as developers. We want to delegate more onto Microsoft and the platform and use more open source libraries. I think one key thing which I find everywhere is, and developers, I suffer from this as well, we don't turn stuff off. It's so easy to spin stuff up in the cloud, right? I literally go through a purging exercise with my teams. And if we were more mindful of the fact that it's so easy now to spin up a service, like 30 to 90 seconds to do something, right? And then you look at it like 3 months later and go, oh, what was I doing? Is it critical? Oh, I better leave it, right? And then it's there for the rest of the year until you start thinking, oh, my bills are going up, and then you go through a purge. But these things need to be more into our consciousness, because at the moment we're thinking about this in terms of cost control, because it's very, very easy to slide down that slope with Azure by not understanding what you've got deployed. But I think if we build this into our sort of mindfulness, that it becomes much easier, and we'll probably find, as I did with one customer project, that just by going through this annual purge, we cut out about 25% of the compute that we were doing, which was unnecessary. 25% carbon saving, and added to the fact, being able to collect those metrics as well, right? There's been an explosion because it's such a brilliant tool. It's such an easy tool to build reports on, but there's been an explosion of Power BI reports. Right, we went through an enterprise customer of ours. We looked at all of the metrics. For a part of the organization to understand who was actually consuming the Power BI dashboards. And of over 100 of these that had just popped up over the last 2 years, 90% of them had one or less user. But they were all backed by data pipelines, they were backed by relational databases. So continually test yourself, right? It was in the GSF norms right at the start, right? Continually test yourself to see whether or not this software is used or not. Okay, I am gonna go on to the last piece if I've got time, right? We'll just run through quickly. And then similarly, we have the idea of the web developer. I've just noticed the word crap. I do apologize for that. It's not my word. But basically, I'm going to go on to the next slide to avoid that now. If we think about the design from the top down, and this is something that I'm thinking about at the moment, after I after I went through these slides. It's very, very easy with the web, and especially with this idea of single page applications, to start firing off thousands of requests, right? This is something that we want to limit. And, thinking about design where we can pull in data up front so that we have to do one request within a session, for example, and then cache and store, and then update that so that we're doing that asynchronously, but maybe not on a request response, right? It becomes very, very important, because if you've got 1 million users on this application and that page is responsible for 10 requests, but I can cut that down to 5, right? The scale impact of cutting 50% of the compute, right, back to the web server, right, becomes tremendous at that stage, just by being a little bit more efficient with your code and thinking, on my page startup, I'm going to pull down, I'm going to go to this JSON API endpoint. I'm only going to do it once, and then I'm going to cache it. And then I'll maybe wait 10 minutes because I know that's going to be refreshed, but I'm happy to have that level of latency. So there's some things that we can think about here. And when I was going through this, these are really, really interesting things. I wouldn't have even thought of taking an image and not using Google Maps, which is incredibly computationally expensive. So it's things like this which we can bring to the fore with web. And then continually asking ourselves about experience, and the user experience, and you can see here at the end of this that 100 million people using your service, right? And thinking about the impact at scale, rather than just thinking, I'm going to build an SPA and, you know, I'm just going to make all these calls left, right, and center. I mean, it's one of the things that I found really good to do this kind of thing in Azure is Azure has a service called App Insights, which actually builds all of this for you. And there's some understanding of the user journey, whether or not it's too long, right? You can go through a website and have a really long narrative until you buy something, or you can just go step 1, 2, 3, and then you're through your journey. So when you think about the latter and you think about the fewest steps that you need to do to either make a decision or get a piece of information, right, we're back to that using less compute, and as a result of it having less carbon pressure. And so as part of this, it covers the whole sort of design end-to-end phase. As I said, that shorter journey, I think that the analysis tools that you can put in place within Azure are absolutely fantastic. You know, you link these websites, you can build funnels, you can look at the user flow as well. So you don't need to actually build anything to assess this yourself, because it comes free in dashboards out of the box. So eco-design is good. I just wanted to leave this with one passing thought. You can see that I'm one of the things that I found as over the last couple of years is Microsoft have probably, to my understanding, they've put out a lot of great content regarding sustainability. It's fantastic that you can go onto the Microsoft Learn site and you can do a course in the green software principles. It's under an hour. It would be great for that course to be bigger than that. I really hope there are plans, because I think it should definitely be part of core material for some of the study and certifications. AI for Earth, I think, is a phenomenal program that Microsoft have created. Very, very, very underrated. You never hear about it. The only reason that I did was because we worked on a biodiversity project for eMammal. Oh, sorry, I'm getting funny looks from there. But it is a fantastic program of work, and it's got loads of. It's had a huge impact. It's had a huge impact, but personally, I don't think it's widely circulated enough. Then you've got the planetary computer, which gives you data sets that you can use. We've been talking about the availability of data. This is literally a bootstrap for both data and compute. It supports Python clusters using Dask, so that you can go to the planetary computer interface. You can probe things like weather data, climate data, things like that, and begin to think about how to build that next-gen sustainable solution. And of course, Microsoft Cloud Sustainability, which is in preview at the moment and is shaping up to be a really good tool. Anyway, thank you very much. That's it.
Cool. Thank you so much, Richard. So we were a little bit over on time. So are there any burning questions? If not, we might hold fire until the later kind of Q&A panel where we can bring them together then. Anything desperate? No, cool. Okay, so we'll take a quick break. So we'll be back here at, say, 5 o'clock. So 15 minutes again. Take it from there. Thank you. Okay, we shall commence. So we've got our panel discussion now. So Chris Lloyd-Jones, who you've seen today from Avanade and also leads the open source community group for GSF. He's going to lead that. So I'll hand over to you and you can do the introductions. Cool.
Thank you very much. So yeah, we're here today with our 4 panelists from our co-host organizations. I'm going to ask each person to just recap their name, where they're from and what they do, and then I'll go through some questions. As we go through, feel free to raise hands. We'll have a dedicated time at the end as well. So starting with Simon.
Thanks, Chris. My name's Simon Turner. I'm the CTO for Data and AI for Avanade UK and Ireland. Spend most of my time working within the Azure environment, helping our customers look at how technology will help them. We have a particular focus on renewable energies.
Wonderful. I'm Asim Hussain. I am the Executive Director and Chairperson of the Green Software Foundation, and I'm also the Green Cloud Advocacy Lead at Microsoft. And my focus for a couple of years now has been trying to look at sustainability through the lens of software and people who are in the business of building software and trying to find answers for them.
Awesome.
Good afternoon. My name is Julie Combet. I am part of Accenture. I am a director in technology sustainability for UKI practice. And I am also director in our UKI software engineering group. In my role, I look essentially these days at technology sustainability and how we help our practices adopt a lot of those concepts we've heard about today and help our clients in their sustainability roadmap and how we bring the technology for them. And then in software engineering, it's more my old background with helping clients move to the cloud and transform their IT.
Awesome.
Hi, so I'm from Goldman Sachs. I'm a VP Tech Fellow, responsible for basically the global platform for our global markets division, which is basically the trading arm of the firm. So our global team effectively manage, hundreds of thousands of cores of compute. And so understandably, a lot of what has been talked about today has been incredibly interesting, and I look forward to the discussion.
Awesome. Well, Indy, you are in the hot seat with your hundreds of thousands of cores of compute, so you will get the very first question. Sure. That is, green software is such a new topic that there are hardly any training or any courses to address it. So what can companies do to enable engineers to practice green software?
Sure. So I wrote down 5 key points.
Great.
That I think is quite key. And number 1, I think, has been talked about quite a lot today, is awareness. So really getting engineers within your organization to actually consider green software. Everybody knows about performance, everybody knows about testing, writing secure code. I think understanding the ramifications of software is quite key. And so that, I think, is the first and foremost thing I would encourage. So that was 1. 2, I'd say, is inventory. So inventorizing, within your organization, what your compute landscape actually looks like. So actually being very prescriptive and trying to make that very clear. So inventory is the second. Measurement, that's been mentioned countless times today. So really understand usage and wastage and putting hard numbers behind that. And also the corresponding ramifications with respect to CO2 emissions. 4th, I'd say, is presentation. So we've talked a lot about data. One thing I don't know whether we've touched on is actually making the data actionable and meaningful. And when I mean that, I mean throughout your whole organization, from your developers all the way to the C-suite and everybody in between. So being able to basically look at the CO2 implications of the software that they write at every level. And finally, I guess, again, this has been touched on a lot, is education. I think one of the things that will become very apparent as we start to go through this journey is, as engineers, one of the things that engineers are great at is coming up with solutions to problems. And I think one of the things we need to do as a foundation is to just to encourage that across all engineers. really instill that mentality of trying to design optimal software.
Yeah, I think that's great. And I really like the focus there on evangelism and awareness. So Julie, same question to you. How would you enable engineers to practice green software? Where should the focus be?
So I think I agree with you. Awareness and knowledge and training is the key element. And just on this point, we are internally in our practice looking to develop some fundamentals around green software. But we are keen to see those external certification that the foundation are going to bring, because I would really bring that standardization and this external setup that everyone can follow. And just to add on that, we'd love to see also on the Azure certification, AWS and Google, that they bring into their own certification, this type of thing. So this is more looking at the future. But to right now where we are, to get our people to learn, there is a number of elements like the Green Coding Hackathon, where we see a lot of involvement and people are interested and passionate, and it's a great way to learn and to exchange on the topic. So that's also one of the area we try to practice.
Awesome. So we had the internal there, we had the data and presentation, and we've had kind of external courses. Asim, in your roles, how would you tie that together? How can you follow that?
You could start a foundation.
That's a good start.
That's a good start. I think it's a question like how do we kind of bring this practice and knowledge to, you know, it's the kind of the vision of the foundation is kind of how do we make this, so this is the culture of building software, so this is just standard. You know, you mentioned it's all about education. I think that's because that's very, very key, and that's one of the beliefs I've always had. My background is engineering, and so I have a firm belief that if you just give them the tools and knowledge and the training, that a lot of the solutions will come from them, surfacing up to the top. We have many conversations around this topic. They're in the foundation about like, where will the change come from? Will it come from the engineers kind of, and not just engineers, I don't want to avoid that term, practitioners, software practitioners, people who are in the business of building software? Will the change come from them? Or will it come more from CIOs kind of coming down and setting the tone and the stage? Or will it come from kind of middle? There's another idea about middle management, like there's a middle out strategy, which is, and there's a feeling that, you know, without working with the middle management of an organization, nothing will really happen, because they will stop any initiative from the top reaching the bottom, and they will stop any initiative from the bottom reaching the top. Kind of everything is my argument. You really do have to hit all the nails, all of it, to kind of get this change kind of top to bottom. And you know, we're looking at different things, and the policy working group is looking at ways where we could encourage changes which are not engineering related, which kind of encourage an organization to adopt these standards, which can affect it on all grounds.
Yep, so there definitely have been some strong debates. We've got the idea there of quashing the middle manager.
Yeah.
So Simon, with your perspective, how would you tackle training green software engineers or roles more broadly than that?
It's an interesting question. I would probably start slightly controversially in disagreeing with the question, because I get the demand that the green software concept is new, but the learnings that we've taken from the last 40, 50 years of developing software, it's more of a re-awareness of where we started from. I'm possibly slightly older than most people here, but a question for the audience: how much could you store on an 8-inch floppy disk? Now, you see, most people won't even know the relevance of that question, let alone what a floppy disk is.
Any hands in the air for that one? Anyone wants to go for it?
So it's 128K. So if you had a PDP 1173, now I'm really showing my age, that's the sort of medium that you were working on. But it meant that you had to be conscious of every line of code that you were writing, because it took up space. Being driven by slightly different agendas in terms of space and cost of storage. And we've lost awareness of that. We've made storage almost infinite. We've created massive processing centers where people are almost given that luxury of not having to worry about those types of constraints. And I think it's more of becoming aware of what that means again. And as an engineer, like Asim, focusing on those engineering principles was kind of geekily fun in the old days. You had to think about every line of every bit of code that you were writing and what that created underneath. And I think that's really where I'd like to start, is that creating that awareness again.
There's a hand up.
Sorry. Yeah.
Thanks. What you were just saying just sparked off a thought in my head. So you were thinking about an old problem, which is about computing with very limited resource. And so when you think about a part of the world where that problem is being worked upon right now, does the Green Software Foundation have a part of it that's based in Africa, where people are developing applications with very limited resources and are really innovating in a very different way to the way we're doing it in the West?
I mean, I can certainly speak from an Avanade point of view and Accenture's perspective, and we have a lot of developers in Asia and across India and also in Africa, and it is very much something that's part of the consideration there. If I'm being sort of honest from a personal point of view, I think it's driven by slightly different perspectives in terms of cost of the compute resources we have there, but it is definitely something that's being focused on in that space.
Go for it.
Yeah, I can't think of anything in particular, but one of the mission director of the foundation is to be as representative as possible, and it's something that I spoke about at the start. So there are members from all over the world, and we've got a large contingent from Asia, especially. I can't speak to whether they have kind of different kind of challenges as you've just described, and whether that leads into any of the decision making and kind of the thoughts. But yeah, it is important for us to be as representative of the whole world, because everybody has something to add to this story.
Yeah, and there's definitely people focused on disconnectivity. That's possibly one for us to take away, maybe connecting with the Open Source Africa group. I did like the focus there, both on disconnectivity and also bringing back patterns and practices that we used to have to do when we were trying to be really performant with a very small amount of memory. I got burnt myself in my first interview saying developers were lazy, and that was the only quote that got taken out of context. So my next question here is for Julie. So as an organization which is new to green software, how would you recommend that organization to start? What are the initial steps they should be thinking of?
So I think a bit like what you said, going back to changing the practice of software development to be green is really a shift in mindset. And I think in large organizations like we are, for example, at Accenture, the challenge is we have practices, and practices, I mean skills and expertise that we group per practices. You'll have your technical architect, you'll have your front-end developer, your back-end developer, your infrastructure engineer, your data engineer. So the challenge is to navigate through all of this complex structure to create that learning we were talking about for a successful change of mindset and adoption. And I think, to your point, the organization needs to tackle it top-down as well as bottom-up. Top-down, so the step would be start with your leadership, with your board, your C-suite, your IT executive. They need to embrace the change, to set the direction, and they need to communicate it, and to include that in their strategy into something very actionable that people, all individuals can just act on. So for example, in our company, our global leadership have made a very clear stance. They communicate, they put it on the website, they've invested in internal training, in tools, and everyone can access it. Now, it doesn't stop here, because you need that organizations support to ripple down that leadership engagement into your local leadership, because the people in different practices will see their leader as a role model. It'll be easier to kind of set up your time aside to think of that if locally your lead is on board. So we're trying to, we go around our organization with tech sustainability on that mission, and we talk to every leader in the different practice, and we try to make them actors of this change. And we ask them to rethink their roles as a DevOps, as an engineer. What would it mean to do your role differently to bring in those sustainable practice? And then you have to keep tackling it through your organization. So training, we discussed, it's absolutely key. The measurement, it's a difficult one. So we start by measuring how many training take-up we have had in the different DT. But the exciting SCI measure will be able to help us standardize and maybe measure the outcome, which it's a bit more complicated at the moment, but that's probably for the future. And obviously keep innovating and keep talking about it transversally across everyone, like we mentioned the hackathon, but we see a lot of passion and engagement, so we need to use that to create that change in the organization.
I like that. I might be injecting my own words here, but going back to the vision, it sounds like then trying to change the culture across the whole of the company. So I'm going to start from the opposite end here, rather than picking on Indy for a second time. So starting with Simon, would using renewable energy help easing climate impact versus having just to recode everything? Basically, should we just swap to renewable energy? Wouldn't that just solve everything?
No. Okay. You want me to elaborate on that? I mean, clearly it would make a difference for a short period of time, but I think you've only got to think back to the comments that Richard made in that last session. The rise of data that we're seeing and the increase both in compute and data usage is so much that we have to find a proper systemic way of sorting out the issue. And again, to Julie's point there, understanding how we use data. I think the quote was it only 30% of data is actually actionable. That means we spend 70% of our time on data that really isn't creating value. And if I think about my own home situation, I think 90% of the data that comes down my internet line is cat videos. Now, I don't know quite whether there's a way of measuring that, but I think thinking more structured about where we spend our time is super important. It's not going to be solved simply by switching to renewable energy. We've got to think about how we do things for the long term now, not just in that short term game. We have to be able to set ourselves up for the zero carbon goals that we've got, and even being able to get into the negative realms, which I think is a number of organizations. I know Microsoft's got that goal by 2050, is it, to be negative?
I don't know, we might find out next, hopefully.
Is it 2030? Wow, super ambitious. But I think we have to be able to make wholesale changes in the way that we do that processing, not just through renewable energy.
I like that. Cat videos, quality content, but also thinking systemically. So Asim, onto yourself, should we just swap to renewable energy? Why are we recoding everything?
I think there's no.
Okay, same answer. Expand.
So I think this, I believe this stat is correct. I'm trying to remember it correctly, but I think on average data centers, from a dollar cost of outright cost to run a data center, about 10 to 20% is the energy. And about 50% is the depreciation of the assets. So like the servers themselves. So like the servers are actually, you have to get rid of them after 3 or 4 years. And the rest of it is just the rest of the overhead of running a data center. I hope I'm accurate about that. Please double check.
Those are high stats.
Stats. That's where I get my stats from. Just count. And so energy from a data center perspective, like energy is important, but it's the embodied carbon that is the biggest emitter of carbon emissions, and so therefore, a lot of what we're talking about in terms of increasing server utilization, use more of the servers instead of using fewer of the servers, that actually has a bigger impact than just purely the energy play. I think what's interesting when it comes to the kind of renewable story isn't how much are you using, but how are you helping the energy transition. It's all about the energy. It's all about the transitioning the whole world towards a 100% renewable powered grid. And what can you do in order to make that happen? Every organization should be having 100% renewable commitment, because then that's financially helping renewable power plants get built. If you take it a step further and you do a 24-hourly, 24/7 kind of 24/7 hourly matching is kind of this level above 100% renewable commitment. Won't go into it. There's about 4 people in the world that understand it. Anyway, and that is, if you make that kind of commitment, that again takes you just a little bit further towards the energy transition. I think that's where there's an interesting story when it comes to renewables and software, is how do you help accelerate that energy transition through your actions? Yeah.
So I'm going to try and distill those thoughts again into just a few words that don't quite do it justice. We have thinking systemically. We have the accelerating the energy transition, but also thinking beyond the carbon in your software from the energy, but also the carbon that's trapped in the creation and destruction. Okay, Julie, renewable energy, is that the solution?
The magic solution? No, I agree with you.
Number 3.
I think so first, I think the transition, the renewable energy transition, are still a long way to go. I think I've read UK estimate that by 2030 they'll be on 30-45%, and it's only an estimate. It's not a commitment. And the energy, we have the population growing. The energy is going to continue to be a constant complex question that we need to be resolved. So we need to do our part, and we need to keep the thinking of reducing the energy. And it's a plus, in both of them needs to be progressed through.
Yeah, good point. I heard the UN announced that we hit 8 billion today. So yeah, that's certainly a very relevant point. So yeah, indeed, same question. Renewable energy, is that our salvation?
Shall I be controversial?
Please, please.
I won't. I have to no as well. The rate of growth of both data and computation is just too large. Like renewable energy as a single contributor to addressing the problem is certainly is not going to be the only thing we need to consider. One thing I'd just like to touch on as part of this question is we've talked a lot about green software, but I think the gentleman from Microsoft, he kind of mentioned architecture, and architecture is kind of going to be foundational to address a lot of this problem. So not just looking at code and the way we write code, so the bubble sort versus the quick sort, and looking at those concerns, but also things like, I think it's been touched on today as well, like usage of libraries and where that plays a part. Other areas, things that we're thinking about are things like monoliths versus distributed systems. So, there's definitely, if you look at the past decade, there's been a massive shift towards microservices, APIs, but there's an extent to which, you can take that to the nth degree. And, that has an impact, that has a cost. And so, I'm not suggesting we go monolith again, but there's a balance to be struck in terms of architecting systems. One of the things was sort of data locality and resiliency. And so those, again, are sort of green architecture principles that I think we need to start thinking about.
Yeah, no, some good points for sure. So good design can trump the actual usage of the software itself. Never give me a mic. I'm trying to get the word demassification to catch on. That's systems just being disconnected. Question now for Simon. How can I get green software on the CEO or C-suite agenda? What does it take?
Costs, I think. I think being, and that's slightly flippant, but I think trying to understand where the return on investment is from approaching things in a green way is hugely important. The really obvious one is cost. If we can do things in a more performant way, if we can make things more efficient, it will save costs. And that's the easiest, obvious way of raising it to the sort of C-suite agenda. But there are organizations, there are clients that we've got that believe that doing the right thing will pay dividends in the long term. And they understand the importance of being seen to be doing the right thing. So I think that's the big shift that we've seen over the last 18 months, 2 years. I think the awareness of corporate responsibility from a social perspective, I think, is now really starting to take its effect. People are becoming much more aware of it. But again, that's that key word again, is awareness. If you talked to a lot of the people in the C-suite about the code optimization, they're not really interested in all of that. But if you can explain to them why that's important and how that will help them from a corporate perspective, that I think is the way to get their attention, but also to show them that it's not just something that's going to cost them money. This is something that can be done efficiently. It can be done in a productive way.
So because I heard someone mentioning it in the coffee area, and I think it builds on this question quite nicely, is this just greenwashing and tinkering on the edges?
No, most definitely not, because I think this is to the point that's come out from all of the presentations and all of the conversations that we've had today. It needs to be measurable. It needs to be something that we can instrument properly. And also, to that previous question, if we are able to re-architect, rewrite a lot of the libraries that we use, to Indy's point, we can then start scoring the libraries that we're using, and we will then be able to create much more of a cumulative view of the overall systems that we build, because we're going to continue to use disconnected models, decoupled solutions. We need to be able to understand what the service is. And one of the questions that came through from the chat, given we work in a layered world, what's the expense of the layers below? We need to be able to see that. We need that level of instrumentation. So it has to be measurable. And that's really where avoiding that greenwashing, for me, is where that will come from.
Okay, great. I like that. So Indy, building on that, so the financial services industry are heading towards being more sustainable in many aspects, including their engineering operations. Where do you think the industry as a whole stands in terms of achieving the climate commitments they've set out to achieve?
So let me touch on some of the challenges of the financial services industry to begin with. So we run a very sort of mixed workload environment. So if I had to talk about trading, we run low latency algorithms that have very different characteristics to something like end of day batch processing, where we're calculating risk and highly distributed processes running across, like I mentioned, thousands of cores of compute. Now, in the latter scenario, we're in the fortunate position where we can safely pack as much software as we can on a given machine. In the former, the ramifications of packing software where low latency is a consideration is simply something we can't afford. So I think one of the key challenges within financial services is to quantify what the spectrum of applications are, and understanding how you then marry that up with some of the constraints that are now coming into the fore with regards to green software. So those, I guess, are the kind of, I don't know whether they're unique, but there's certainly challenges within sort of the financial services domain. And some of the things that we're doing in that regard to try and surface some of this up. And this again is not just a symptom of financial services, but potentially for very mature organizations that have, potentially decades worth of compute and software, running in production today. And so one of the challenges we've got, which we're trying to overcome, is, again, a lot of people have been talking about data and data science and observability and actually understanding what their software is doing. One of the things that we're doing is to start to look at things at the very finest level. So you mentioned like 128 kilobytes on a floppy disk. I had 16 kilobytes on an audio tape. So we're kind of getting to the really low level of what software is doing. And so some of the characteristics there, we're looking at every single process. So in Linux, everything runs as a PID. Everything opens a socket connection. API calls are done over that. So we're monitoring sort of ingress bytes, egress bytes on every single process across this massive estate. And so one of the things that will allow us to do is to actually understand, it gives us visibility on our sort of infrastructure, but it also then allows us to start to think about some of the things that have been talked about today, which is how can you quantify in highly complex distributed systems, what is the energy consumption? And the way we do that is through sort of understanding, power consumption on our underlying hypervisors. So, these are stuff that, a lot of firms are starting to look at now.
I heard challenges there, but I also heard a lot of detail and some quite optimistic thoughts for where the industry is going. And I'm sure some of those challenges resonate in other industries too. So before I open up to the floor, the people in the room and the chat, the final question is for Asim. He's not seen this question before. So in 5 years' time, where would you want the Green Software Foundation to be, and where would you want the tech industry as a whole to be?
I should have because we're working on it, aren't we?
Yep.
You're tricky. We're having these planning discussions right now. He's put me on the spot. So I really like some of the, because we've been having some conversations today in the foundation regarding kind of what are our long-term goals? Like, what are we looking for? We talked about, we want to change the culture of the industry, bring sustainability up to, to make it part of the culture of building software. And there's stuff that people have mentioned earlier on. I think Fergus was talking about it. Well, that there are things other than carbon as well that we need to think about. And when we really, the ultimate goal of what we're trying to achieve here, it is, there should be, if you're building software or using software, there should be no adverse environmental effects. That's basically it. If you're building software or using software, there should be no adverse environmental effects. That is the ultimate goal that we're aiming for. We're not going to get there in 5 years' time, and nowhere near, but that's kind of that's kind of the ultimate goal. If you ask me in 5 years' time, and we talk a lot about the education and training, the certification, I just think that is so key to building up that awareness across the board. I get a lot of questions about, well, how do I do X? What is the tooling? Well, how do we measure Y? There is so many gaps in the tooling out there that we need to flesh out in order to enable people to kind of do a lot more work in this space. And I hope in 5 years' time we'll be in there as well. And I think those are I haven't really thought 5 years ahead, but those are some of the key things I
Awesome.
to get.
Time horizon might vary. Zero environmental effects. You heard it here.
Yeah.
Are there any questions in the chat or in the room? Yep, just over there.
I was just wondering, with all the thought leadership, quantifying like really complicated measurements when it's multi-layered, etc., how much of it is backed by rigorous science, or what is your approach? Are you collaborating with universities or research groups? I just want to know what's like what the rationale is.
So the way we work inside the foundation is everything works via consensus. So everything that is, so for instance, if there's a proposal for a methodology or anything really, it goes through a consensus process, means everybody has to agree. And so that, and we have various academic institutions included. We've got various nonprofits, a lot of for-profits. So a lot of eyeballs go onto everything. Specifically, we do engage with on a more rigorous level with academic institutions. We're working very closely with Texas State University in applying this software carbon intensity specification to series of machine learning models. But yeah, generally that consensus model is something we're very proud of. Any organization, no matter how large or small, if they don't agree with anything, they just have to say the words, "I object," and that stops the process, and it forces everybody to come to a consensus, on that. So that's kind of the mechanism that we have, that, to kind of come to an agreement on these issues, and come to an agreement in a fair way, which means that doesn't matter the size of your organization, you can't bully your way into anything. We have a very fair organization. Does that answer your question? Yeah.
Hi, thanks so much. Just the whole day has been really incredible. And I've been wondering, so you're talking about the certifications that you want people to do so that the practitioners are certified and have the knowledge. But is there any thoughts around, and I guess this is for the panel as well, whether it would help the companies as well, certification or some kind of auditing that can be done on sites? I work in academic publishing, and for us, accessibility has been talked about for the last 5 years, and only recently we have to do it because there's certifications and auditing and that kind of thing. And that makes companies say, yes, we're going to put resources. Is there anything around this that you're thinking about in the foundation, and would the other panelists on the group, would that help in your companies to have such a certification?
So I think you're talking about certifying not a human being to that they know something, but certifying a product.
Yes, yeah.
To say that product is green.
Yeah.
Yes. No, so the policy working group. So one of our working groups, the policy working group, is working on a. We haven't got a great name for it yet because we've got green software certification. We might call it green product certification. But how do you certify a product? Be it a software service or a laptop, I don't know. How do you certify it for being green? What does that really look like? It's very, very early stages in those conversations. So we don't really know where it's going to go. It will probably start off initially as a checklist. So we'll publish a checklist that you can then ask yourself of a service provider. You can put in a request for quote, and you can just copy and paste it in and say, well, look, if you want my money, answer these questions about how you're going to build this piece of software. And then that maybe will evolve into something a bit more certified, where we ask those questions, we certify them beforehand. So that's something we're looking at. Extremely early days in those conversations.
Sorry, Simon. So I mentioned earlier as well, sorry, I lost my chain of thought there, I felt really bad. So there's the Global Reporting Initiative as well, which is an accountancy standard, which does actually already monitor environmental impact as well as e-waste. It looks at carbon. So if you're an audited company, your accountancy firm can also look at that. And then, because I'm being tapped for time to free people up for networking, we're going to go to the panel to also answer that question.
So I just wanted to ask a question for the audience. Who's got a packet of crisps or biscuits with them at the moment? So have a look on the back of that packet of crisps. You know exactly what's in that. You know the calorific value. Do you know the carbon footprint for that packet of crisps? Because I think probably the answer on that is no. I mean, I can see, to your point, I can see a time where we actually have to understand the carbon impact of the software that we use, the libraries that we use. And in the same way as I honestly believe that we will with the products that we buy in a supermarket as well. And I think that's when we start to change the awareness and our ability to make choices, educated choices on the software that we use and the way that we build systems, and also the food that we eat as well.
I had not thought about that, and I think the concept is amazing, and it makes absolute sense. It's like having a label on your food if it's green, and I was thinking it's also probably something that we can apply also to organization, like we do have in IT. Certain organizations are certified because they, and probably the concept can be brought even further and forward. And I think we see across the business, the policy, just there is this push from every direction, from those labels that brings the consumers to kind of consider what they buy, as well as probably the policies. Maybe they'll also think of bringing something here on the table to the software that gets released. I mean, with metaverse and everything coming, it's not just carbon; it's also the ethic part of the software. So I think there is a lot to do, a lot of challenges that's coming, and I think this idea is a great one. So one more for your 5-year plan for the foundation. Yeah, sorry.
Yeah, I think it has to happen, right? But I think one of the challenges we've got as engineers is it's challenging. Like the number of variables that go into play to assert that something is green, we're still trying to figure that out. So, you know, like I booked a flight a month ago, and now I noticed, when taking a flight, they now, next to the price, they say the carbon emission of the flight you're about to take is this. Now, being able to do that for highly complex distributed systems is going to be challenging, but we definitely have to overcome that. As to how we get there, I don't know. Hopefully we'll find out next year.
We've got one last question, but depending on how complex it is, I might ask we take it at drinks, but you can ask it.
So I was thinking of embedded carbon. Is there an equivalent green hardware foundation?
There is actually an open compute project, part of the Linux Foundation, which does look at the standards for hardware, yes. And I can answer that one. Great. Over to you.
Okay, should we have a quick round of applause for our panelists? Thank you. It's a great discussion, and thank you for the questions as well. That was awesome. So I hope you've enjoyed today. I think there's been a lot covered. I think everyone's pretty open to discussing and kind of keeping the conversations going. So hopefully you have all joined the meetup group, but I think the big kind of call to action from a global software foundation community perspective is maintaining the conversation in that community. So meetup is a kind of home for that. Hopefully you've joined that as part of this process, and we look forward to seeing you through there. We've got some food. We hope it's sustainable. We've got some drinks as well. So please hang around, keep the discussion going, and we'll hopefully see you soon.
That's online as well. And there will be a closing summit broadcast online around the 17th as well at summit.greensoftware.foundation.
Cool. Thank you, Chris. And thank you to all our Zoom attendees as well. We hope that we did a good job of including you. We did keep an eye. There wasn't any questions from them in the last section. So yeah, thanks everyone. Enjoy.